स्टूडेंट्स। तो आज है हमारा डे 31 जेई 40 डे क्रैश कोर्स सीरीज का। और आज का हमारा टॉपिक है ऑर्गेनिक कंपाउंड कंटेनिंग हैलोजेंस। तो ये है डिस्क्लेमर। तो सबसे पहले हम ये देखेंगे कि हम आज के लेक्चर में कौन कौन से टॉपिक्स कवर करेंगे। तो सबसे पहले हम बात करेंगे फिजिकल प्रॉपर्टीज ऑफ हेलोएल्केन्स एंड हेलोएरीन्स। After that, we will cover about nature of CX bond. After that, we will look towards the chemical properties of haloalkanes. After that, we will study about the chemical properties of haloarenes. So, let's start with today's lecture. The first thing which we are going to study is the physical properties. So, let's start with the physical properties of alkyl and aryl halides. Talk about haloalkanes and haloarenes, they have significantly higher boiling point than the corresponding hydrocarbons of comparable molecular mass. Now, if we talk about the boiling point trend, then first we will talk about the polarity. So, we know that in CX bond, where X is any halogen, so the CX bond is polar bond, because we know that the electronegativity of halogen is high. So if the electronegativity of halogen is high, it will take the shared pair of electron towards itself, which gives it a partial negative charge. Okay. So because of the CX bond polarity which is present there, it leads to the dipole-dipole interactions between the molecules. And this attractive force, along with the strong van der Waals force, it requires more energy to overcome than the weaker forces which is there in non-polar hydrocarbons. And thus it increases the boiling point. Because if something which is held by a stronger force of attraction, so you need to give more energy to break that force. Okay, so that is why they have high boiling points if we compare it with the hydrocarbons of comparable molecular mass. So now if we look at the trend of the decreasing order of boiling point of alkyl halides, then if we talk about the given alkyl group, the boiling point the boiling point increases with the size and mass of the halogen atom. So if we look towards this iodine, bromine, chlorine and fluorine, we know as we move down the group from fluorine to chlorine to bromine to iodine, the size increases as well as the mass also increases, right? So the boiling point increases with the size and the mass of halogen atom. Okay? This is because the larger atom have more electrons, which increases the van der Waals, which increases the strength of van der Waals dispersion forces. So if you look towards this trend, first is Ri, then it is Rbr, then it is Rcl, and at last we have Rf. Okay. Now if we talk about the effect of alkyl chain size. So boiling point increases with the size of alkyl group due to the greater surface area and corresponding increase in the van der Waals forces. Okay, so if the size of the alkyl group increases, your boiling point also increases. Okay, so this is because of more van der Waals forces. So if I compare between CH3CH2Cl, okay, and CH3Cl, so CH3CH2Cl will have a higher boiling point as compared to CH3Cl. Okay. Now moving on further, now we will talk about the effect of branching. Okay. So if we talk about the effect of branching, we are talking about the isomers. So for isomeric alkyl halides, that means they are compound which have the same formula but they have the different structure. Okay, so for isomeric alkyl halide, the boiling point decreases with increase in branching. Now, why this happens? Because branching, this happens because if we talk about the branching, so the branching makes the molecule more spherical. So think like that, if something is making the molecule spherical, its surface area gets decreased. So if its surface area gets decreased, its van der Waals force also decreases. Okay, so it weakens the van der Waals force. So that is why when branching increases, the boiling point decreases. Okay, so if we talk about, then generally first comes the primary alkyl halide, then comes the secondary alkyl halide, and then comes the tertiary alkyl halide. Okay, so as I told you, you need to remember that straight chain alkyl halides, they have higher boiling points as compared with the branched chain isomer, okay, of similar molecular weight. So if you look at this given example to you, you look, we have CH3, CH2, CH2, CH2Br. Okay, this is one molecule. Another molecule, we have CH3, CH2, CH. There is one branch on this carbon, which is Br, and we have CH3. Okay, and then we have this given molecule. So if you look, then a straight chain molecule, they have larger cylindrical surface area, okay, which allows for the greater contact between neighboring molecules. So this maximizes the strength of van der Waals force. Okay, so that is why if you see this molecule, which is a straight chain molecule, this has the highest boiling point among these two. All right. And if we talk about increased branching, so increased branching, as I told you, makes the molecule more spherical, that is more compact. So this decreases the overall surface area, which makes it available for intermolecular contact. So the reduced surface area, it results in the weaker van der Waals forces, and consequently less energy is required to separate the molecules, which leads to a lower boiling point. Okay, so this is one bromobutane, then we have two bromobutane, and then we have two methyl. Okay, we have two bromo, two methyl propane. So if you look towards their boiling point, first is highest, then comes the second one, and then comes the last one. So I hope the reason is clear to you now. If you look at the last one, there is more branching. That is why its boiling point is lowest. Okay, now if we talk about the bromo and iodo derivatives, so the bromo and the iodo derivatives of hydrocarbons, they are heavier than the water. Okay, that they are heavier than the water density, that it is greater than 1 gram per milliliter. Okay, so lower chloroalkanes and fluoroalkanes, they are typically lighter than the water. Okay, now if we talk about the solubility, so haloalkanes and haloarenes, they are very slightly soluble in water. Okay, look towards the reason for their slightly soluble or insolubility in water. So haloalkanes and haloarenes, they do not form hydrogen bonds with water. Okay, it is clearly mentioned that they do not form hydrogen bond with water. Now, although they are polar, okay, we know that they are polar. Although they are polar, for dissolution to occur, the energy released upon forming new attractive forces between the halide and water molecule, it must be greater than the energy which is required to break the existing attractive forces. Okay, so the forces is water water, where there are strong hydrogen bonds, and halide halide, where there are dipole dipole and van der Waals forces. So since the new attraction formed between the halide and the water molecule, they are weaker than the original hydrogen bonds in water, so they are unable to overcome these forces effectively, okay, which leads to the lower solubility. Okay, so I hope this is clear. If you have any doubt, you can ask me in the chat box, okay, regarding the topic which we are discussing. Okay, now moving on further, so we are talking about the nature of CX bond. All right, so as I already told you about the polarity of carbon and X bond, carbon and halogen bond. So we know that the electronegativity of the halogen atom, which is denoted by X, it is greater than that of the carbon atom. Okay? Now, because of this difference, the shared pair of electrons in the CX bond, it is pulled closer to the halogen atom, because the one which will be more electronegative will take the shared pair of electron towards itself. Okay, so it will pull the electrons towards itself. Who? The halogen atom. Okay, so what happens due to this? This creates a partial negative charge on the halogen atom and a partial positive charge on the carbon atom, which makes the CX bond polar. Okay, now if we talk about the trends in the bond length. Okay, so when we are moving down the halogen group, that is from fluorine to iodine, the size of the halogen atom increases. Okay, so consequently, if the size is increasing, the carbon halogen bond length also increases from CF to CI. Okay, because as the size is increasing, their strength, their bond strength is, if we talk about the bond length, when the size is increasing, the bond length between the carbon and the halogen bond, that also increases. Okay, so first is CI, then comes CBr, then comes CCl, and at last comes CF. Okay, so this is the bond length order which I told you. All right, now if we talk about the CX bond in haloarenes, so if we talk about in haloarenes like in chlorobenzene, okay, so the CX bond is between a halogen atom and the sp2 hybridized carbon atom of the benzene ring. So similar to haloalkanes, this bond is also polar due to high electronegativity of the halogen. Now, however, due to resonance and the sp2 hybridization, the CX bond in the haloarenes, they have a partial double bond character, and it is shorter and stronger than the CX bond in haloalkanes. Okay, so what is the hybridization of carbon in haloalkanes? It is sp3 hybridized, whereas if I talk about haloarenes, it is sp2 hybridized. So it gives a partial double bond character, which makes the bond short as well as strong. Okay, now we move towards the chemical properties of haloalkanes. Okay, so see over here that haloalkanes, they are highly reactive compounds because of the presence of polar RX bond. Okay, because as I told you, the carbon and X halogen bond, halogen being more electronegative, takes the shared pair of electron towards itself, giving the carbon a partial positive charge and the halogen a partial negative charge. Okay, so this positively charged carbon is susceptible to attack by electron rich species. Now see over here that carbon gets a partial positive charge. Okay, so now it is in hunger of more electrons. So, if any species that is electron rich, which is mostly nucleophile, okay, so that attacks that carbon atom, because now that carbon atom is susceptible to a attack by a electron rich species. So, if we look towards the reaction of haloalkanes, they are of three different types. Okay, first is nucleophilic substitution reaction, then it is elimination reaction, then comes the reaction with metals. Okay, so these are the three types of reaction which we will see one by one. All right, first we talk about nucleophilic substitution reaction. Okay, so nucleophilic substitution reaction, they can be of two types, SN1, SN2. Okay, so what happens in a nucleophilic substitution reaction, that a nucleophile, it reacts with a it reacts with a haloalkane which has a partial positive charge on carbon atom which is bonded to the halogen. Okay, because carbon is in need of electrons, so a nucleophile which is electron rich species will attack on electron deficient species which is a carbon in the carbon and halogen bond. Okay, So this reaction can proceed by SN1 or SN2 type of mechanism. Okay, so one by one we are going to read about both the two types, that is SN1 and SN2. Okay, so first we are going to talk about nucleophilic substitution unimolecular, that is SN1. Okay, so if we talk about SN1 reaction, then it is completed in two steps. Now see, this SN1 and SN2 is very important. Okay, so you need to understand the concept of SN1 and SN2. So as I told you, your SN1 reaction, which is nucleophilic substitution unimolecular, it gets completed in two steps. The step 1 is a slow step. Okay, what happens in step 1? The carbon and halogen bond, it breaks to form a carbocation, which is an intermediate. Okay, and this step being a slow step, this is a rate determining step, that is, it is RDS. What happens in step 2? The nucleophile, it rapidly attacks the planar carbocation. Okay, so this happens in these two steps. Now if I talk about the kinetics of this order, so it is very important to note that it allows first order kinetics. Means that the rate of the reaction, it depends only on the concentration of the substrate. So many times the question is being asked, they ask you that SN1 follow which order kinetics. So you should know it follows first order kinetics, because rate is equal to K into concentration of substrate. Okay, so this K is rate constant. So this only depends upon the concentration of substrate. Okay, it is independent of the concentration of nucleophile. It is only depending on the concentration of the substrate. Alright? Okay. Now, so as I told you about this reaction, which is SN1 reaction, so a carbocation is formed. Now what happens is that carbocation is getting formed, so their rearrangement of carbocation also takes place. So in step 1, as I told, a carbocation is formed. So this intermediate is highly reactive. So if the initial carbocation formed is not the most stable, okay, it may be a 1 degree carbocation is formed. So if the carbocation which is formed initially is not a stable carbocation, so it will get rearranged if it is possible. Okay, so what happens in rearrangement? So rearrangement like a hydride or a methyl shift, it occurs quickly to convert a less stable carbocation to a more stable one. Okay, so which carbocation is more stable? Tell me, 3 degree, 2 degree or 1 degree? 3 degree carbocation is more stable, 2 degree carbocation or 1 degree carbocation? So if you see, then 3 degree carbocation is more stable. Then comes 2 degree and then comes 1 degree. See why? Because if you see, then in 3 degree carbocation, the carbon which is having a positive charge is further connected to 3 carbons. Alright, that means 3 methyl groups. If I am taking example of methyl, so it is connected to 3 methyl groups. Now these methyl groups, which effect they show? They show plus I effect, right? So by plus I effect, they are stabilizing the positive charge of that carbocation. And because 3 methyl groups are present, so you can see it's stabilizing more of that positive charge as compared to 1 degree where only one CH3 group is present. Okay, so that is why 3 degree carbocation is more stable. So if initially 1 degree is formed and if there is any possibility of rearrangement to form a 3 degree carbocation, then it gets rearranged to form a more stable carbocation. Alright. Now if we talk about the favorable conditions, then if we talk about substrate, so a tertiary alkyl group 3 degree favors SN1. Okay, this is because 3 degree haloalkane form the most stable carbocation, which lowers the activation energy of the rate determining step 1. Okay, as I told you, 3 degree one is more stable. Now if we talk about the solvent, so a polar solvent, specifically polar protic solvents like water or methanol, So a polar solvent, it favors SN1. Okay, so this solvent, it stabilizes the carbocation intermediate and the halide leaving group through solvation, okay, which drives this reaction forward. Now see what happens is that, now if we talk about the stereochemistry, so stereochemistry is another important aspect. First, as I told you, there is a carbocation intermediate. Then I told you it rate depends only upon the concentration of the substrate. Now another important aspect is its stereochemistry. So what happens, since the carbocation intermediate is planar, that is everything is in the plane, it is planar. So, so if something is planar, so nucleophile can attack either, can attack the carbocation from above and below the plane with approximately equal probability. See, if this is a carbocation, the nucleophile can attack either from above or either it can attack from below. So so it is equal probability from where it will attack, from above or from below. Okay. So therefore, if the reaction occurs at a chiral center, I'm talking about a chiral center. So if the reaction occurs at a chiral center, the product that is a product that is an equal mixture of two enantiomers called a racemic mixture can be formed. Okay, so this process is known as racemization if there is a chiral center. Okay, so equal mixture of two enantiomers, which is called a racemic mixture, it can be formed. All right. Now, if you look carefully, we have this example. Okay, so we have step 1 and step 2. First, look towards this example. So, this is a hydrolysis of tertiary butyl bromide. All right, so if you see this reaction, this shows the hydrolysis of tertiary butyl bromide to form a tertiary butanol. So, step 1, what happens? The tertiary butyl bromide, it loses a bromide ion and it forms the stable 3-degree tertiary butyl carbocation. Okay, so see, it loses a bromide ion and it forms a stable 3-degree carbocation. So if you look at this carbon, which is a center, it is further connected by 3 more carbons. Okay, so this is a 3-degree carbocation which is very stable. So here there is no possibility of rearrangement because you already have a stable carbocation. So this is step 1 and this is the slow step and it is the rate determining step. Okay, now if we talk about step 2, okay, then what happens in step 2? In step 2 you can see the nucleophile, which is the OH minus, it attacks the carbocation to form the final substitution product. Okay, so this is a nucleophile which is OH minus, it will attack this carbocation, okay, and it will form the final substitution product, that is tertiary butanol. Okay, so this is a tertiary butanol. This is a tertiary alcohol. How? Because the carbon to which your OH is connected is further connected by 3 carbons. So this is a tertiary alcohol. Okay, so this is how SN1 reaction takes place. So it is very important, SN1 and SN2. If you have any doubt, you can ask me right now about SN1 mechanism. Okay, then we will talk about SN2 also. So I hope SN1 is clear to you. Okay, so what happens in step 1? There is formation of a carbocation, and if there is possibility of rearrangement, then that happens. And in step 2, the nucleophile attacks that carbocation and forms your product. Okay, okay, then let's move forward. Now we will talk about nucleophilic substitution biomolecular. Earlier we talked about unimolecular, which is SN1. Now we will talk about biomolecular, which is SN2. So look at this. Now this reaction is completed in one step. Okay, unlike unimolecular, which is completed in 2 steps. If we talk about bimolecular, which is SN2, this is completed in one step. Okay, now further what happens? So here primary alkyl group and non-polar solvent, it favors SN2. So as I told you, the nucleophile attacks the substrate and the leaving group, it departs at the same time. There is no intermediate which is formed in this reaction. Okay, so the difference should be clear between SN1 and SN2. In SN1, there was a carbocation intermediate. What happens in SN2? The nucleophile it attacks the substrate and the leaving group departs at the same time. Okay, so there is no intermediate which is formed. And another important thing is that it follows second order kinetics. Okay, that is the rate of the reaction, it depends upon the concentration of substrate as well as the concentration of the nucleophile. So that is why it follows second order kinetics. Okay, so it depends upon both the concentration of substrate as well as the concentration of nucleophile. Now, as I told you, there is no carbocation which is formed. Okay, since the reaction is concerted, means it happens in one step, there is no high energy carbocation intermediate. Okay, so instead of that, a transition state is being formed where the attacking nucleophile and the departing halogen, they are both partially bonded to the central carbon. Okay, look, I will show you with the diagram. If you look at this diagram, this is the transition state which I'm talking about. There is no carbocation formation, but this is a transition state. Okay, because reaction is concerted. So what happens? The transition state is formed where you're attacking nucleophile. So this is your OH minus, which is the attacking nucleophile. So you're attacking nucleophile and the departing halogen. This is the Cl, which is the departing halogen. So you're attacking nucleophile and the departed halogen. They are bonded, both partially bonded to the central carbon. So this is a transition state which is involved in SN2 mechanism. Okay. Now if I talk about the substrate and solvent preferences in this, so see over here, primary alkyl group, that is 1 degree, it favors SN2. And the reactivity order is first comes methyl, then comes 1 degree, then comes 2 degree, and then comes 3 degree. Now why this happens? This is just opposite of SN1. In SN1 it was 3 degree, 2 degree, 1 degree. Here it is just opposite of that. Now why it happens? This is because the nucleophile attacks from the back side of the carbon halogen bond, and a less hindered, which is less bulky substrate makes the attack easier. Look what is happening. This is a nucleophile. It attacks from the back side. So if this will be hindered or sterically hindered, it will be difficult for it to attack. Okay. So if it is less hindered or less bulky, then that substrate makes the attack more easier. That is why it is written primary alkyl group favors SN2. Okay. Now moving on towards the solvent part. Okay. So non-polar solvent like polar aprotic solvents like DMSO or acetone or DMF, they favor the SN2. Okay, so these solvents, they stabilize the transition state without strongly solvating the nucleophile, allowing it to remain highly reactive. Okay, talk about the stereochemistry. Okay, stereochemistry, it involves inversion of configuration. So this is very important. In SN2 there is inversion of configuration. Okay, so the nucleophile attacks the central carbon from the back side, which is just the opposite of the leaving group, that is the halogen. So this simultaneous attack and the departure, it causes the tetrahedral configuration of the carbon atom to be momentarily inverted. Okay, similar, like you can think of an umbrella which is turning inside out if there is a strong wind. Okay, it is very similar to that. So this results in a product with a configuration that is completely inverted related to the reactant. So this is known as Valdane inversion. Okay, so if you look over this, if you look at this reactant and now if you look at the product, there is inversion of configuration. Why? Because there is attack, the nucleophile attacks from the back side of the reactant. Okay, so it is very important to remember there is inversion of configuration and this involves Valdane inversion. Okay, so if you see this example over here, we have a methyl chloride. Okay, so the OH, which is the nucleophile, it attacks the carbon from the side which is opposite to the chlorine atom. So if this is the side of the chlorine atom, it will attack on the side which is opposite to the chlorine atom. Okay, so what happens in a transition state, a 5 coordinate intermediate state which is a transition state, is formed where the carbon is simultaneously bonded to OH, which is partially formed bond, and Cl, which is the partially broken bond. Okay, because now this OH is attaching to it and this chlorine is leaving. So this is transition state which is involved. Okay, and what happens, the chlorine, it leaves as Cl minus, and the OH bond, it forms a new bond. Okay, so there is inversion of the geometry. Okay, if you see the hydrogen atom, they are flipping its side. If you see here, it is this side, and here it is this side. So they are basically flipping the sides. Okay, now if you look about this wedge solid bonds, so the solid bond means it is towards the viewers. Okay, and if we are looking towards dash bond, then it is away from the viewers. Okay, so if you are viewer, so then solid is towards the viewer and wedge is away from the viewers. All right. Okay, now we will talk about nucleophilic substitution bimolecular. We'll continue with it. Now if we look towards the reactivity of SN2 mechanism. Okay, so here if we talk about, first let's talk about the SN1 mechanism, which we studied earlier. So talking about SN1 mechanism, which is nucleophilic substitution unimolecular, the reaction is completed in two steps. Okay, as I told you, it follows first order kinetics. That is, the rate depends only upon the concentration of substrate. So step 1 is the slow step. Okay, so the CX bond, which is the carbon and halogen bond, it breaks to form a carbocation intermediate. Okay, and if there is possibility of rearrangement of that carbocation, that carbocation rearrange, okay, to form a more stable form. That is step 1. Now what happens in step 2? The nucleophile attacks the planar carbocation. Okay, so tertiary alkyl groups and a polar solvent, that is H2O or CH3OH, it favors SN1. Okay, so the reactivity order is first 3 degree, then 2 degree, then 1 degree, and last is CH3X, because the tertiary carbocation is very stable compared to secondary and primary. Okay, so if I talk about stereochemistry, the nucleophile, it can attack from above the plane as well as it can attack from below the plane of the carbocation. So if the starting material is chiral, okay, then a racemic mixture can be formed. Okay, so hydrolysis of, like if we talked about the hydrolysis of tertiary butyl bromide. Okay, we talked about its example. Now if I talk about SN2, okay, which is nucleophilic substitution which is biomolecular. Okay, so if you look at this, that first it is CH3X, then comes 1 degree, then comes 2 degree, and last comes the 3 degree. Okay, so if you see over here, 1 degree, 3 degree is last over here. Why? Because it is a more bulky one. So if a nucleophile will attack, it will hinder it. Okay, so if I talk about the steps in kinetics, then the reaction is completed in one step. Okay, I'm talking about SN2. And it gets completed in one step, that it is concerted. It follows second order kinetics. That is, the rate depends upon the concentration of substrate as well as on the concentration of nucleophile. Okay, and if I talk about mechanism, then in case of SN2, no carbocation is formed over there. Okay, so a single transition state is formed where the nucleophile, it is partially bonded to the carbon and the halogen is partially bonded and it is departing. That means it is leaving. Okay, so if I talk about substrate and solvent preferences, then primary alkyl group, which is 1 degree, and a non-polar solvent, which is like DMSO or acetone, it is preferred. Okay, so reactivity order, it is already given to you. 3 degree comes last because of the steric hindrance. And if I talk about stereochemistry, then the nucleophile attacks from the backside of the leaving group, causing a complete inversion of the configuration. Okay, that is the Valdane inversion. Now if we look towards this nucleophilicity as well as on the strength of nucleophilicity strength and the rate of SN2, then in SN2 mechanism, the rate of reaction, it depends upon the strength of attacking nucleophile. Stronger will be the nucleophile, faster will be the reaction. So here you can see the strength of different nucleophile is given. First is Cn minus, then I minus, then OR minus, then OH minus, then CH3COO minus, then comes H2O, and then comes F minus. Okay, so Cn is the strongest one. Okay, so the stronger nucleophile will lead to the faster reactions. Okay, I hope this is clear to you now. Okay, moving on forward, now we will talk about some basic stereochemical principle and notations. Now we will talk about optical activity and about the polarimeter. Okay, now first let's talk about optically active compounds. So there are certain organic compounds when in solution, they have the ability to rotate the plane of polarized light as it passes through them. So these compounds which has this ability of rotating the plane polarized light, they are called as optically active compound. So what happens? Ordinary light, it vibrates in all directions perpendicular to the direction of propagation. And plane polarized light is the light that vibrates in only one single plane. So if I talk about the device or instrument which is called as polarimeter, so the angle by which an optically active compound, it rotates the plane polarized light, it is measured by an instrument which is called as polarimeter. Okay, and this angle, it is often denoted by alpha. Look at this figure. In this figure, the angle which is this is denoted by alpha. Okay, now if you look at this over diagram over here, this shows you how a polarimeter works. Okay, so first is this ordinary monochromatic light. This is the light of the single wavelength. Okay, so this ordinary monochromatic light, it is used as the source. Then this light passes through the Nicol prism, or we can say it is a polarizer. So it passes through a nickel prism which converts the ordinary light into a plane polarized light. Okay, then what happens next? This plane polarized light, it then passes through the substance. Okay, this is the substance, that is the solution of the organic compound. So now this plane polarized light passes through this substance, and if the substance is optically active, it rotates the plane of light by an angle which is denoted by alpha. Okay, and the emergent light, it is then analyzed by a second prism. Okay, so for now, if you need to remember that if the compound is optically active, it will rotate the plane polarized light by an angle which is called as alpha. Okay, now moving on, we will talk about some stereochemical principles. Okay, so first see, if we talk about the direction of optical rotation, so the rotation of plane polarized light is classified based on the direction. First is dextrorotatory and another one is levorotatory. First, let's talk about dextrorotatory. So if the substance, it rotates the plane polarized light in a clockwise direction, it is known as dextrorotatory. It is denoted by plus or like this, which is shown in the slide, or D. Okay, so it rotates the plane polarized light in clockwise direction. Okay, so dextro comes from Latin word which is for right. So like that you can remember. Now if we talk about levorotatory, so it is just opposite of dextrorotatory. So if the substance, it rotates the plane polarized light in anti-clockwise direction, that is to the left, it is known as levorotatory, and it is represented by minus or it is represented by N. Okay, now moving on further, let's talk about chiral carbon. So a chiral carbon, okay, a carbon that has four different groups or atoms which is attached to it, that is called as chiral carbon. Okay, if we talk about this, then this asymmetry is responsible for a molecule's chirality and optical activity. Okay, so if we talk about a chiral molecule, then we can say an optically active molecule possesses at least one chiral carbon atom. Okay, that means all the group which is attached to that carbon, they are different. So a chiral molecule is one that cannot be superimposed on its mirror images, just like your right and left hands. Okay, now we talk about racemic mixture and racemization. Then, if what is a racemic mixture? So a mixture that contains two enantiomers, that is dextro and levo, in equimolar amounts, that means in equal amounts. That is called as racemic mixture. Okay? If I further talk about, then a racemic mixture is optically inactive because the rotation which is caused by one enantiomer, it is exactly cancelled out by equal and opposite rotation which is caused by another enantiomer. So this cancellation is referred to as external compensation. Okay, so that is why racemic mixture is optically inactive. Okay, so if I talk about racemization, so the phenomenon where a pure enantiomer is converted into a racemic mixture. So this process commonly involves during the SN1 reaction due to the formation of a planar carbocation intermediate, okay, which the nucleophile can attack from either sides with equal probability, that is from above also and from below also. Okay, now look about SN2. When we were discussing about SN2, there I told you about Valdane inversion, right? So if I talk about SN2, this is a concerted nucleophilic substitution reaction, okay, which is typically seen in primary and secondary alkyl halides. So the nucleophile attacks the carbon atom from the side opposite of the leaving group. So there is inversion of configuration. So the backside attack, it forces the three other groups on the carbon atom to flip their position. Okay, much like umbrella, which I told you that example. So this gives rise to a product whose configuration is exact opposite to that of the reactant. Okay, so this 100% inversion of configuration during SN2 reaction, this is known as Valdane inversion. Okay, so this reaction converts a molecule from one enantiomeric form to another one. For example, if the reactant has R configuration, the product will have the S configuration and vice versa. Okay? Okay. Now we will talk about elimination reaction. Right now we talked about substitution reactions. Okay, we talked about chirality, enantiomers, racemic mixture, racemization. Now we will move towards elimination reaction. Okay. So what is elimination reaction? So what happens? This involves beta elimination, okay, or we call it as dehydrohalogenation. So when a haloalkene, which is a alkyl halide, is heated with alcoholic KOH, that is potassium hydroxide, a beta elimination reaction takes place. Now if we look towards this mechanism, what happens? This reaction involves the removal of a halogen, which is represented as X. So it involves the removal of halogen atom from the alpha carbon, which is the alpha carbon, the carbon which is bonded to the halogen. So it involves the removal of a halogen atom from the alpha carbon and the hydrogen atom from an adjacent beta carbon. So look over here, the carbon to which your halogen is bonded is called alpha carbon, and that adjacent is beta carbon. So halogen gets removed from alpha carbon and the hydrogen gets removed from a beta carbon. Okay, and what we get is a resultant alkene, which we get in this elimination reaction. Okay, so if you look at this overall reaction, this involves the removal of HX, okay, which is dehydrohalogenation. Okay, and it results in the formation of an alkene. Now here we are talking about a rule which is called as SATHEE rule. Okay, now what is the SATHEE rule? So if the haloalkane, it has more than one beta hydrogen atom. Okay, now look here in the given example. Here we have only one beta carbon. Okay, so we have only one beta hydrogen. Now if there are more than one beta hydrogens that is available to you, from where will you remove the hydrogen and form an alkene? That is the question that should arise in your mind. So a Sedgwick rule, it answers to your question that if the haloalkane has more than one beta hydrogen, okay, that is the multiple beta carbon with hydrogen atoms available for elimination. So the elimination of HX leads to the formation of more than one possible alkene product. So now which one will be the major alkene or which will be your major product? So the Sedgwick rule, it is used to predict the preferred product in such dehydrohalogenation reaction. Okay, so what does this Sedgwick rule says? The rule says that the preferred product is the alkene that has greater number of alkyl groups which is attached to the doubly bonded carbon atoms. Okay, so you can summarize it as the more substituted alkene is the major product. Okay, which has greater number of alkyl groups which is attached to the doubly bonded carbon atom. Okay, now look at this reaction. Okay, you have two bromopentane. At second carbon, a bromine is attached. Now you have two pathway. Path 1, which is the Sedgwick product, and path 2, which is the Hoffman product. Now first look towards when you react it with KOH, alcoholic KOH, in first you are getting pent 2E. Now if you look over here, there is the elimination of hydrogen from beta carbon, that is the carbon 3. 1, 2, 3. Okay, so here if you will see, there is the elimination from the carbon 3. Look from here, this is 1, 2 and 3. Okay, we are counting from which side? From left hand side. Okay, so if you look at there, then there is elimination from carbon 3 and it yields pent 2ene. Alright, and if you further see the second one, it is pent 1ene. Okay, so there is the elimination from the elimination of hydrogen from the beta carbon, that is carbon number 1. Okay, which yields pent 1ene. Now if you look towards first one, it is 81% and second one is 19%. So the major product is the Sedgwick product because the double bond is more substituted. Okay, it has two alkyl groups which is attached to it, and the second one is only 19%. Okay, this is the minor product because the double bond is less substituted. Okay, so I hope now you know that if you are having more than two beta hydrogens to eliminate, you will get multiple products. The one which is the most, which has more number of alkyl groups, the doubly bonded carbon, okay, that one will be your major product, and the left one will be your minor one. Okay, okay. Now last we will talk about reaction with metals. Okay, so what happens with that? First we will see the reaction with magnesium, that is the formation of Grignard reagent. So haloalkanes, that is RX, it reacts with magnesium metal, that is Mg, in dry ether to form Grignard reagents. Okay, so look at this reaction. We have CH3CH2Br. When it reacts with magnesium in presence of dry ether, we get a Grignard reagent, that is CH3CH2MgBr. Okay, so Grignard reagent, these are your organomagnesium halides and they are very much reactive, they are highly reactive. Okay, so they must be prepared and handled under anhydrous conditions because they react readily with water to form your alkanes. Okay, now if you say there are some more important reaction of haloalkanes. Okay, so these reaction, it involves the use of ambident nucleophile. Okay, now what is an ambident nucleophile? A nucleophile that can attack through two different atoms. Okay, so here your product depends upon the nature of the salt, that it is whether ionic or it is covalent. Okay, look at the first reaction. You have your reacting agent as AgNO2 and the product you are getting is RNO2 plus AgX. So this is a nucleophilic substitution reaction and the product which is formed is nitroalkane. Okay, so AgNO2 is mainly covalent. So the lone pair on the less electronegative nitrogen, it is free to attack, which results in RNO2. Alright. Now if you see the second one, we have NaNO2 or KNO2. Okay. So here what you are forming RONO. All right. So, and if you are seeing, you are also getting KX or NaX. Okay. So if you see this, you are getting an alkyl nitrile in this case. Okay. So if you look towards this alkyl nitrile, so KNO2, it is predominantly ionic. So it gives NO2 minus ion. So the attack occurs preferentially through the negatively charged oxygen, which forms RONO, which is alkyl nitrile. Now, if you look at the third one, you have KCN or NaCN. And the product which you are getting is RCN plus KX or NaX. Okay. So, if you see over here, then we can see the last one, which is RX, AgCN, which gives RNC plus AgX. Okay. So, if we talk about AgCN, then in this you are getting an alkyl cyanide one. Okay. So if we talk about AgCN, then AgCN is predominantly covalent. So this attacks, it occurs through the less electronegative nitrogen, which forms RNC, okay, which is isocyanide. And if I talk about this one, then KCN, it is mainly ionic in nature. Okay. Now students, we are going to solve some questions on the concept which we have studied right now. Okay. Okay, now let's start with the questions. So we will see some practice questions. Okay, let's move on to the first question. So what is the first question saying? So carbon chloride bond is stronger than the carbon iodine bond. Why? First is because carbon chlorine bond is more ionic than carbon iodine. Next is carbon chlorine bond is polar covalent bond. Next is carbon chlorine bond is more covalent than carbon iodine. Or D is carbon chlorine bond length is longer than carbon iodine. So tell me which one is correct, A, B, C or D. So one of the among four options will be the correct one. You have to answer which one is correct. So tell me which one is correct one. So if you look towards the solution, then you will see that option number A is correct. Okay, that is the carbon chlorine bond. It is more ionic than carbon iodine bond. Okay, so if you look towards the dipole moment for carbon chlorine bond, it is 1.56 dBi. And if you look for the carbon iodine bond, then it is 1.29. Okay, which is less as compared to the carbon chlorine bond. Now, if I talk about the bond strength and bond length, then shorter bond length generally means a stronger bond. So, if I talk about the halogen size and we move down the group in periodic table, that is from chlorine to bromine to iodine, the size of the halogen atom increases significantly. And consequently, what happens? The distance between the carbon atom's nucleus and the halogen atom nucleus also increases. Okay, so bond length is greater for carbon iodine, okay, and it is shorter for the carbon chlorine. And if I talk about bond strength, then a shorter bond is harder to break because the nucleus of the carbon atom, it is closer to the bonding electrons and the nucleus of the smaller halogen atom, which results in the greater attraction. Okay, so that is why the carbon chlorine bond, it requires more energy to break. Okay, as making it stronger than the carbon iodine bond. Okay, now if we talk about this bond polarity, then We know that chlorine is more electronegative than compared to iodine. So the greater difference in electronegativity between the carbon and chlorine means the CCl bond is more polar. That is why it has a higher dipole moment, okay, as compared to the carbon iodine one. Okay, so that is why you can see that the carbon chlorine bond is more ionic than the carbon iodine bond. So the greater polarity or ionicity in the carbon chlorine bond contributes to the overall bond energy, as there is a strong electrostatic attraction between the polarity, okay, positive carbon and the partially negative chlorine, okay, which is further reinforcing your bond strength. So that is why your option number A is the correct answer. Okay, now let's move on to the next question. It is asking to you that which of the following is used as a methylating agent. Four options are given: C2H5Br, C6H5Cl, CH3Cl, or C2H5Cl. Tell me which one was the correct answer. Which is used as a methylating agent? A, B, C, or D? If you look towards your answer, then the right answer is option number A. That is CH3Cl. Okay. Now, if we talk about a methylating agent, then a methylating agent is a reagent which is used to introduce a methyl group into another molecule. Okay. So, if you see over here, look at this reaction which is shown to you. You have a benzene, which is an aromatic ring, and you have CH3Cl, which is a methylating agent. Okay. If I talk about the catalyst, then we have AlCl3, which is aluminium chloride. So this is a Lewis acid catalyst that helps generate the reactive methyl carbocation, which is CH3+, which is needed for the reaction. So in product, what happens? The CH3 groups get attached to a benzene, which is a toluene. Okay. So this specific reaction, this is a classic example of Friedel-Crafts alkylation, okay, which is used to add the alkyl groups. So if you look, then that is why we can say that CH3Cl, which is methyl chloride, is classified as the methylating agent, okay, because it supplies the methyl group that is added to the benzene ring, forming a toluene. Okay. Okay, let's move on to the next question. So it is asking you that the addition of Hi, that is hydrogen iodide, in the presence of peroxide catalyst does not follow anti-Markovnikov addition because four reasons are given to you. First is Hi is a strong reducing agent. Second is Hi bond is too strong to be broken homolytically. Next is iodine combines with hydrogen atom to give back Hi. And next is that the iodine atom is not reactive enough to add across a double bond. So tell me which one is correct, A, B, C, or D? So if you look towards the solution, the correct answer is option number D. Okay, that is the iodine atom is not reactive enough to add across a double bond. Okay, now if you look what happens if we talk about the peroxide effect, which is the anti-Markovnikov addition, then what happens? The anti-Markovnikov addition, it typically occurs when a hydrogen halide, that is HX, where X can be bromine or chlorine, it is added to an unsymmetrical alkene in the presence of peroxides. Okay, so this reaction, it proceeds by a free radical mechanism and leads to the halogen atom adding to the carbon with more hydrogen atoms. Okay, so it involves several steps. First, if we talk about, it involves initiation. So the peroxide, it breaks down to form a free radical, which then reacts with the HX to generate the halogen free radical, okay, which is X radical. Okay, then what happens is propagation. So the halogen radical, which is the X radical, it attacks the double bond. So the most stable intermediate carbon radical is formed, usually a 2 degree or 3 degree. And lastly is the termination. So the final product is formed when the intermediate carbon radical reacts with the molecule of HX. Okay, so why this HI? If you see, it addition follows anti-Markovnik's. If you see addition of HI in the presence of catalyst, do not follow anti-Markovnikov rule, because iodine radicals, they have more tendency to form I2 molecule as compared to the form free radical of carbon. Okay, so thus iodine atom is not reactive enough to add across a double bond. So this I radical, it combines with I radical to form I2 molecule. Okay, instead of making carbon radical and propagating the chain. So that is why your option number D is the correct answer for this question. Let's move on to the next question. So you have to consider the following bromides. Okay, you have molecule A, you have molecule B, and you have molecule C. Okay, now you have to tell the order of SN1 reactivity in all of these three. Which one will be the most reactive towards SN1? Okay, recall whatever I told you about SN1. Okay, what I told you, it involves the formation of the carbocation, and your stability of the carbocation is upmost over there. Okay, that means a stable carbocation should be formed. So which one will be the more stable? First, remove the halide and form the carbocation, and then check the stability of the carbocation. Which one will be the most stable? It will be the correct order. So if you look towards the answer, correct answer is option number A. First is B, then comes C, and last comes A. Okay, now look at the compound one by one. As I told you, the higher the stability of carbocation, the faster is the reaction, because SN1, which is substitution unimolecular, it involves the formation of carbocation intermediate. Okay, so what happens in step 1? Carbocation is generated. Now if you look at these three, look at compound B. So this is an allylic carbocation. Okay, that means if you see over here, when this bromine leaves, this carbon gets a positive charge. So this is an allylic carbocation. So when bromine leaves, it forms a secondary allylic carbocation. So allylic carbocation, they are stabilized by resonance. Okay, that is the delocalization of the positive charge over multiple atoms. So this resonant effect is generally a much stronger stabilizing effect as compared to the hyperconjugation itself, alone hyperconjugation. That is why your B1 is the most stable. Now if you look at C1, then if bromine leaves from here, this carbon gets a positive charge. Now calculate the number of alpha hydrogens which are present. So one, this will be the alpha carbon, one, this is the alpha carbon. Okay, so you have 3, 4, 5 alpha hydrogens that are present over here. So compound C, if you see over here, then in compound C, you have how many? When the bromine leaves, it forms a carbocation, and this is stabilized by the hyperconjugation. Okay, and here we have 5 alpha hydrogens. Okay, and if you look at the A figure, then in A figure, calculate the number of alpha hydrogens. We have 2 alpha hydrogens that are present over here. So that is why C1 is more stable as compared to the A1. Okay, so that is why more stable is B, then C, and then comes the A. Okay, let's move on to the next question. You have to tell the increasing order of reactivity in the SN1 reaction. You have been given 4 options. Okay, tell me which one is the correct one. A, first, second, third, or fourth. Which one will have the highest reactivity in the SN1 reaction? A option is correct, B option is correct, C option is correct, or D option is correct. Okay, if you look at the answer, then option number D is correct. Second one is more stable, then comes the first one, then comes the fourth one, and last comes the third one. Okay, now if you look, then second one is the most reactive, as it produces an aromatic carbocation. If you look at the second one, when this bromine leaves, this carbon gets a positive charge. Okay, and this is most reactive as it produces a aromatic carbocation. While if you see, the fourth one is least reactive as it produces a secondary carbocation. Okay, and this is least reactive as it gives a non-resonance stabilized carbocation. Okay, and if you see, third one is least reactive compared to first one, because third one, it is an anti-aromatic carbocation, which is the least stable one. Okay, so that is why in anti-aromatic one it has 4 n pi electrons. Okay, which is the least stable. That is why your option number D is correct. That is, second is more stable, then first, then fourth, and at last comes the third. Okay. Okay. Now next question. Which the organic chloro compound which shows a complete stereochemical inversion during SN2 reaction. Now as I told you about SN2, there is complete inversion of configuration. Okay, because the nucleophile, it attacks from the side opposite to the halogen atom. So there is a complete inversion of configuration. Now, 4 organic chloro compounds are given to you. You have to tell that which one will show a complete stereochemical inversion. CH3Cl or C2H5 whole twice CHCl, or CH3 whole thrice CCl, or CH3 whole twice CHCl. Okay, tell me which is the correct answer. Option number A, B, C, or D. So if you look towards this answer, correct answer is option number A. Okay. If you look towards the SN2 reactions, then SN2 reactions, they are accomplished by complete stereochemical inversions. Okay, since your primary alkyl halides, they are more prone to SN2 reactions. Okay, so if you look at the among, then CH3Cl over here, as I told you, primary one are the most prone, because if you compare primary, secondary, and tertiary, in tertiary there is lot of steric repulsion, steric hindrance factor that comes into the picture. Because of the steric hindrance, it makes it difficult for the nucleophile to attack. Okay, so if we talk about primary one, and then primary one, there is least steric hindrance that is present over there. Okay, so that is why if you'll see primary alkyl halides, they are most prone to SN2 reactions. Therefore, you will see CH3Cl undergoes complete stereochemical inversion. Okay, that is why option number A is the correct answer. Now let us see the next question. So the increasing order of reactivity of the following halides for SN1 reaction. Okay, again very simple. In SN1, if it comes about SN1, your topmost priority should be to look at the stability of the carbocation. More stable will be the carbocation, more faster will be the rate of reaction. So first is given to you 1, 2, and 3. Okay, you have to tell the increasing order of reactivity. So tell me which one will be the correct answer. Option number A, option number B, option number C, or option number D. Which one will be the correct one? Okay, so if you look towards it, the correct answer will be option number B. Okay, third one is more stable, then comes the first one, and at last comes the second one. Okay, now if we talk about SN1 reaction, then in SN1 reaction, the rate depends only upon the concentration of the alkyl halide. Okay, and this is the slow step, and it is the rate determining step. Okay, so the nucleophile concentration does not affect your rate of SN1 reaction. Now, if you see further, you will see that as I told you, this reaction proceeds by a carbocation intermediate. Okay, so the reactivity is decided upon the ease of dissociation of alkyl halide. So it depends how easily the carbon and halogen bond gets broken. Okay, weaker bond generally tends to break more readily, which increases its reactivity. Okay, so if you look at this given equation, this shows a reversible reaction where an alkyl halide dissociates into a carbocation and a alkyl halide and a halide ion. Okay, so this represents the ionization of an alkyl halide, okay, which is a key step in nucleophilic substitution reaction. Okay, now we will continue the solution. So in SN1, more stable carbocation forms faster, which increases the reactivity. Okay, so now look at the first one. In this first one, we have CH3CO, C6H4, CH2 plus. In this carbon, we have a positive charge. Now, if you see, this one is the most stable one. because of the resonance stabilization. Okay. Now, if we look at the second one, in this we have a positive charge on this carbon. So, this is a 2-degree carbocation because the carbon which has a positive charge is further connected to two carbons. So, this is the secondary carbocation. And you look at the third one, in this we have a primary carbocation because the carbon is only connected by only one carbon. So in this one we have resonance stabilization, in second one we have a secondary carbocation, and last one we have a primary carbocation. Okay, so that is why if you see, if we see the correct increasing order of reactivity, so you will see first comes the this one. Okay, so we will see the benzylic halides, they form the most stable carbocations, which is followed by the secondary one, and at last comes the primary one. Okay, so whenever such type of questions come, look towards the formation of the carbocation. Okay, so a 3-degree carbocation is always more stable than 2-degree and 1-degree. Okay, so thank you so much, students. I hope the lecture and the questions are clear to you. Thank you so much.
Hello everyone. Okay, so today we will practice some question on circle. Okay, at first we'll summarize the theory portion and then we'll practice some question. Okay, so at first we look at the summary for circles and then we practice some questions. So, what is circle? So, as I already defined, so circle is locus of point that moves in a plane and such that the distance from a fixed point, and that fixed point is center, and that is in the plane. So the distance from this fixed point to this point is always constant. Okay, then the locus of that point is center. That fixed distance is radius and fixed point is center. And what is the standard form for equation of circle? So if your center is h comma k and radius is r, then the equation is given by x minus h whole square plus y minus k whole square is equal to r square. This form is also known as central form. Okay, and if we have the end point of diameter, then we can also write the equation of circle. So if the end point of the diameter is given x1 y1 and x2 y2, then we can write the equation of circle, that is x minus x1 x minus x2 plus y minus y1 into y minus y2 is equal to 0. Okay, now if the circle intercept the axis, then we can find the length of intercept, that is made by the circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. So with x axis the length of intercept is 2 into root under g square minus c, and with y axis this is 2 into root under f square minus c. And equation of tangent, so what is tangent? So a line which touches the circle only at a single point, that is your tangent. And there is a different form for equation of tangent. We already discussed the point form, the slope form, okay, the parametric form, the different form. Equation of normal, so the line, if we draw the tangent, so the line that is perpendicular to that tangent, that is your normal. And we also discuss the different form of equation of normal. Next is what is pair of tangent. So if we have a given point, so we can draw pair of tangent to the circle, and according to the point, is the point lie outside the circle, inside the circle, or on the circle. So if the point lie outside the circle, we can draw two real and distinct tangent to the circle, and if the point lie on a circle, then we draw coincident tangent, and if a point lie inside the circle, then that tangent is imaginary tangent. Okay, next is what is director circle. So director circle is the locus of point, and that locus of point is intersection of two perpendicular tangent to a given circle. So if you draw two perpendicular tangent to a given circle, then the point of intersection of this both tangent, then if we take the locus of that point, then that is your director circle. Next is chord of contact. So if we have a point, so the point we draw two tangent from that point to the circle, which is outside. Okay, so when we join the point of contact of that both tangent that we drawn from that point to the circle, then that line is chord of contact. Okay, next is pole and polar. So what is pole and polar? So point is pole and a fixed line, that is polar. So how we get this? So let's suppose we have a point P x1 y1, and that is can be inside and can be outside the circle. Then we draw that we drawn any straight line to meet a given circle at Q and R. So we draw a straight line that is passing through a point x1 y1 and cut the circle at Q and R. Then we draw the tangent at point Q and R, and where they intersect that point. So when we take the locus of that point, and that is we get a straight line, and that line is polar with respect to the pole x1 y1. Okay, what is conjugate point? So if we have A and B are 2 points, then these 2 points are called conjugate point with respect to a given circle if each lies on polar of the other with respect to the circle. And same as conjugate line. So the two lines are said to be conjugate if pole of one lies on other. Okay. And how to find angle of intersection of two circles? So if we have two circles, then we have to find the angle of intersection. At first we draw the tangent at that point of angle of intersection for both circle, and then we find the angle between the tangents, and that angle is angle of intersection of two circle, and that is given by cos theta is equal to r1 square plus r2 square minus d square by 2 r1 into r2. Okay. Orthogonal circles, if the angle of intersection of two circle is 90 degree, then that two circle are called orthogonal circle, and they said to be intersect orthogonally. Okay. There is different condition for family of circles. First one is the equation of family of circle which passing through the intersection of circle, and the equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, and the line is lx plus my plus n. So the point of intersection is the circle is intersect with this line, then the family of circle that is passing through this intersection is given by x square plus y square plus 2gx plus 2fy plus c plus lambda time lx plus my plus n is equal to 0, or it can be written as s plus lambda time L is equal to 0, where lambda is any real number. S is the base circle and L is the equation of line. What is radical axis? So the radical axis of two circle is the locus of point which moves in such a way that the length of the tangent drawn from it to the circle are equal. Okay. And coaxial system of circle. So this is a system of circle that is said to be coaxial system circle. If you take any pair from that system of circle, then they has the same radical axis. Okay. So let's start question. Let's discuss some question based on circle. So the first question is the circle passing through 1 comma minus 2 and touching the x axis to 8 3 comma 0 also passes through the point. Okay. So there is a circle, and what is the information about this circle? This circle is passing through a point 1 comma minus 2. Okay. And another information is touching the x axis to at 3 comma 0. So there is a circle that is touch the x axis at 3 comma 0. So the line, the x axis is tangent to the circle. Clear? So we have to find which points is passes through the point. So for that we can find the equation of circle by using this condition, and then we can substitute these points to figure out which points satisfy the equation of circle. Okay. So try this question. So how we can write the equation of circle that passing through 1 comma minus 2 and touching the x axis at 3 comma 0. Okay, let's solve. So correct answer is C, 5 comma minus 2. So the formula that we use, first one is equation of circle touching x axis at a comma 0 is given by x minus a whole square plus y minus 0 whole square plus lambda time y is equal to 0. So how we get this formula? The family of circle, that is s plus lambda time L is equal to 0. Here equation of line is y is equal to 0. Why? Because the touching of x-axis, it means this line is tangent to the circle, and that equation is given by equation of x-axis is y is equal to 0. So equation of line is y is equal to 0. Okay, so we get x minus a square plus y minus 0 square plus lambda time y is equal to 0. Okay, so let's solve. So equation of circle that is touching the x-axis at 3 comma 0 is x minus 3 whole square plus y minus 0 whole square lambda time y is equal to 0, as it is given that this is passing through a point 1 comma minus 2. So this equation must satisfy this point. To substitute this point, we get 1 minus 3 whole square plus minus 2 whole square plus lambda time minus 2 is equal to 0. So from this we get 4 plus 4 minus 2 lambda is equal to 0. So we simplify this and we get lambda is equal to 4. So substitute back the value of lambda, we get x minus 3 whole square plus y square plus 4y is equal to 0. So this is the equation of circle. Okay. So by hit and trial method, we substitute the points, the given points on option. So we see that the point 5 comma minus 2 satisfy this equation. So this point must lie on the circle. Okay. Clear? Next question. AB is chord of the circle x square plus y square is equal to 25. So we have a circle x square plus y square is equal to 25. It means this is a circle with center at origin and with radius 5. Okay. The tangent of A and B intersect at C. So we draw tangent to the circle at a point A and B, and that tangent is intersecting at a point C. If 2 comma 3 is the midpoint of AB, then area of the quadrilateral OACB is, okay, so 2 comma 3 is the midpoint of AB. So we join the point A and B, so we get a chord, and the midpoint of that line segment AB is 2 comma 3. Then area of this quadrilateral that we form OACB is, options are option A 50 into root under 13 by 3, option B 50 into root under 3 by 13, option C 50 into root 3, and option D 50 by root 3. Okay, so try this question. At first try to draw this figure according to the condition given in question. Okay, at first draw the circle with center 0 comma 0 and radius 5, that is x square plus y square is equal to 25, and then take 2 point A and B on the circle and draw the tangent at that 2 point, that is intersect at C, and then join A and B, and that 2 comma 3 is midpoint of this AB. So we form a quadrilateral OACB and we have to find area of this quadrilateral. Okay. So what is the formula to find the area of this quadrilateral? Okay, let's solve. The correct answer is option B, that is 50 into root under 3 by 13. Okay. The formula and key points that we use. The first one is we use distance formula, that if we know the 2 points on a, that is x1 y1 and x2 y2 be 2 points, then the distance between these 2 points is given by root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, and this is the figure how we draw. At first we draw the circle x square plus y square equal to 25, that's center at the origin 0 comma 0 and with radius 5. This is a circle and radius OB and OA is 5. Okay. Then we take a 2 point A and B on a circumference of circle and we draw tangent to this point. So AC and BC is the tangent to the point A and B. Okay. And we join the point A and B, so we get a chord, and the midpoint of this is 2 comma 3. So the point coordinate of P is, that is the midpoint of AB is 2 comma 3. Then we have to find area of quadrilateral OABC. Okay. So we know that area of quadrilateral is given by OB into BC. So we have to find OB, the length of OB and length of BC. Okay. So for that we use trigonometry. So as OB and OA is 5 radius of length 5. So from the triangle OPB, so consider the triangle OPB, sin theta is P by H, that is OP by OB. So we have to find the length of OP. So as coordinate of OA, that is origin, is 0 comma 0 and P is 2 comma 3. So we can apply the distance formula to find the length OP. So we get root 13. Okay. And what is OB? The radius. So we get 5. So root 13 by 5. Now cot theta. So cot theta is 2 root 3 by root 13. So we can also find the cot theta. Cot theta is B by P, and we know, as we know the value of sin theta, so we can easily calculate the value of cot theta. So we get cot theta is equal to 2 root 3 by root 13. So area of quadrilateral OACB is OB into BC, and the OB is 5 and BC is 5 cot theta. We already calculate the value of cot theta. So we get 25 into 2 root 3 by root 13. So from here we get 50 root 3 by root 13 square unit. So this is the area of quadrilateral. Okay. Next question. Two vertices of an equilateral triangle are -1 comma 0 and 1 comma 0. And the third vertex lie above the x-axis. Find the equation of circumcircle. Okay. So at first draw the figure. We have equilateral triangle and two vertices are given, -1 comma 0 and 1 comma 0. So take a coordinate system and draw these points, locate these points and draw a equilateral triangle. The third vertex lie above the x-axis. Okay. And then we have to find the equation of circumcircle. Options are: option A, x square minus y square plus 2y by root 3 plus 1 is equal to 0. Option B, x square plus y square minus 2y by root 3 minus 1 is equal to 0. Option C, x square minus y square minus y by root 3 is equal to 0. And option D, none of these. Okay, so try this question. What is the relation between circumcircle and centroid of an equilateral triangle? Let's think. At first, draw the figure. Okay. As a hint, circumcircle and centroid for equilateral triangle are coincide. Okay, both are same. And to find equation of circumcircle, we have to find the coordinate of center. That means the coordinate of circumcenter. That means the coordinate of centroid. And also we have to find the radius. Okay, try this question. Anyone? Okay, what is coordinate of the third vertex? Height of a equilateral triangle is given by root 3 by 2 into side. Okay, so use this. And also there is a relation with centroid, the length of centroid OG and the altitude of the equilateral triangle. Okay, let's solve. So correct answer is option B, that is x square plus y square minus 2y by root 3 minus 1 is equal to 0. So how we get this? Let's check. So the formula that we use, first one is in an equilateral triangle, the centroid, circumcenter and in center are coincide. So all are same, centroid, circumcenter and in center. Okay, in case of equilateral triangle. Okay. Second, the distance formula, the distance between 2 points, if the coordinate of points is x1 y1 and x2 y2, then points is given by distance is given by root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so let's look at the solution. Now at first we draw the figure. So as two vertices are given for equilateral triangle, that is minus 1 comma 0 and 1 comma 0, so let a is minus 1 comma 0 and b is 1 comma 0. Okay, and third vertex is lies above the x-axis. So we take third vertex C, that is above the x-axis. Okay, so when we draw the line from the third vertex to the side AB, we do a perpendicular, and that bisect the line side AB. So the coordinate of this midpoint is O, that is 0 comma 0, as the coordinate of A is minus 1 comma 0 and B is 1 comma 0. So the bisected point is 0 comma 0. That means the point C is lies above the x-axis and above this origin. So the coordinate is of C is must of the type C comma 0 comma B type. So at first you have to find what is B, that is coordinate of C, that is height of this altitude. Okay, so as we have AB is 2, the side, the length of this AB, we can also find this length as A is minus 1 comma 0, B is 1 comma 0. So apply the distance formula and clearly we can observe that this distance is 2. So altitude of an equilateral triangle is root 3 by 2 into its side, and side is 2, so we get the height OC is root 3. And as the coordinate of C of the type 0 comma B, so coordinate of C is 0 comma root 3 and the height OC is root 3. And as the circumcenter and centroid of an equilateral triangle are same, so G is G be the centroid of the equilateral triangle, also the circumcenter of an equilateral triangle. So to find the equation of the circumcircle, we have to find the coordinate of G and then we have to find the radius. And if we have the coordinate of G, then we can easily calculate the radius with the help of any vertex. We can calculate the AZ distance by using the distance formula. Okay, so now we have to find the coordinate of G, and for that we have a property of equilateral triangle is that OG is equal to 1 by 3 OC. Okay, so from here we get, as OC is root 3, so we get OZ is equal to 1 by root 3, and as the distance OZ is 1 by root 3, so coordinate of G is 0 comma 1 by root 3. Okay, because this coordinate lies on y-axis. Okay, so x coordinate is 0. So now we find the radius with the help of distance formula. We have the coordinate of A, we have the coordinate of G, so we apply the distance formula, we get root under 1 plus 1 by 3, that is 2 by root 3. So now we have the coordinate of G, that is coordinate of circumcenter, and the radius AG. So we can apply the formula of a circle to find the equation of circumcircle of triangle, equilateral triangle ABC, and that is x minus 0 whole square plus y minus 1 by root 3 whole square is equal to 2 by root 3 whole square. And from here we get x square plus y square minus 2y by root 3 minus 1 is equal to 0. So when you simplify this, we get root 3 into x square plus y square minus 2y minus root 3 is equal to 0. Clear? Any doubt? Okay. Next question. Circle are drawn through the point 2 comma 0 to cut intercept of length 5 unit on the x-axis. Okay. If the center lie in the first quadrant, then the equation for k greater than 0 is, options are option A x square plus y square minus 9x plus 2ky plus 14 is equal to 0. Option B 3x square plus 3y square plus 27x minus 2ky plus 42 is equal to 0. X square plus y square minus 9x minus 2ky plus 14 is equal to 0. And option D x square plus y square minus 2kx minus 9y plus 14 is equal to 0. So this circle is drawn through the point 2 comma 0. Okay, so this circle passes through 2 comma 0. And another information is this circle cut intercept of length 5 unit on the x-axis. Okay, so if the center lie in the first quadrant, another information, the center lie on the first quadrant, then what is the equation of this circle? So try this question. Two comma 0 point lie on x-axis. So we have a point, we have the first intercept by the circle on x-axis 2 comma 0, and then length is given, length 5 unit, intercept of length, cut intercept of length 5 unit. So another point where the circle cut the x-axis is, it can be 2 point, it can be 7 comma 0, or another is minus 3 comma 0. But there is one more condition, that center lie in the first quadrant. Okay, so try this question. Anyone? What is the value of h? Because the main task is to find the value of h. If we consider the hk as the center of this circle, then what is the value of coordinate h? Because you don't need to find the value of k, because all the equation in the option given in terms of k. Okay? Anyone? Okay, let's solve. So correct answer is C. X square plus y square minus 9x minus 2ky plus 14 is equal to 0. Okay. The formula that we use. So first one is equation of circle having center x1 y1 and radius r is given by x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay. So observe this figure. So in this figure, as it is given that the circle are drawn through the point 2 comma 0 and it cut intercept of 5 unit on the x axis. Okay. So we have a point 2 comma 0 and another intercept of length 5. So we get another point is 7 comma 0. We can also draw the circle on the left hand side, that is with the point minus 3 comma 0, but as it given that center lie in the first quadrant, so we get 2 comma 0 and 7 comma 0. Okay, and the distance between them is 5 units and r is the radius and hk is the center of this circle. So clearly the x coordinate of center, that means the value of h. So if you consider 2 comma 0 as point A and 7 comma 0 as point B, then if we draw a line from HK to the line AB to the chord, so that is a perpendicular bisector. So that must be the midpoint. Okay. So we can easily calculate the coordinate of x by using the formula of midpoint, that is 2 plus 7 by 2, that is 9 by 2. So we get 9 by 2. Or if we consider the left hand, if we consider the point minus 3 comma 0, we get the midpoint as minus 1 by 2. But as the center lie on the first quadrant, so we take consider h is equal to 9 by 2. Okay. Now equation of circle. So as we have the value of h, so we have the coordinate of center is 9 by 2 comma k. So we can calculate the radius by using the distance formula. So use the point 2 comma 0 and 9 by 2 comma k to find its radius, and then equation of circle is x minus h, that is x minus 9 by 2 whole square plus y minus k whole square is equal to, apply the distance formula to find the radius. So r square is equal to h minus 2 whole square plus k square, that is 25 by 4 plus k square. Okay. So from here we get, when we simplify this, we get x square plus y square minus 9x minus 2ky plus 14 is equal to 0. So correct answer is option C. Clear? Any doubt? Okay. Next question. Circles are drawn through the point A comma B and B comma minus A such that the chord joining the 2 points subtends an angle of 45 degree at any point of the circumference. Okay. Then the distance between the center is, options are root 3 times the radius of the either circle, option B 2 times the radius of either circle, option C 1 by root 2 times the radius of the either circle, and option D root 2 times the radius of either circle. Okay, so try this question. At first try to draw the figure. We have two circles and information are, first circle is passing through point A comma B and second circle is passing through the point B comma minus A. Okay, such that when we join the chord joining the 2 points subtend an angle 45 degree at any point of circumference. Hello. We have to find the distance between the centers. Okay, so we have to apply the distance formula. But to apply the distance formula, we must have the coordinate of centers. Okay, so try this. Okay, let's solve. Correct answer is option D, that is root 2 times the radius of either circle. Okay. So the formula that we use, first one is coordinate of endpoint of a line are x1 comma y1 and x2 comma y2. Then the slope of the line is m is equal to y2 minus y1 by x2 minus x1. And the distance formula is d is equal to root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so let's see the solution. Figure is not shown. Let's imagine the figure. Okay, so circles are drawn through the point a comma b and b comma minus a. Okay, so we have two circles that is passing through a point a comma b and b comma minus a. Okay, and then we join these points and we make a chord, and this chord subtends an angle 45 degree, and let that point is p x comma y be any point on the circumference of the circle. So we have the coordinate of a, that is a comma b, and coordinate of b is, consider it as point b, that is b comma minus a, and coordinate of p is x comma y, and the angle subtended at a point p by the chord ab is 45 degree. Okay, so let's find the slope of the line PA. So that is b minus y by a minus x. And the second slope, that slope of line PB is minus a minus y by b minus x. So we have the angle APB, the angle made by the chord AB to the circumference at a point P. So the angle is 45 degree or 135 degree. Okay, we get two angle. So we have a formula for angle by using slope. So that formula is m1 minus m2 by 1 plus m1 into m2 is equal to 1045 degree or 1035 degree. So what is the value of 1045 degree and 135 degree? That is plus minus 1. So we get, substitute the value of slope. So we get b minus y by a minus x minus minus a minus y by b minus x by 1 plus b minus y by a minus x into minus a minus y by b minus x is equal to plus minus 1. Simplify this equation, we get b minus y into b minus x plus a minus y into a minus x by a minus x into b minus x minus b minus y into a plus y is equal to plus minus 1. So we get two equation, with one with plus 1, one with minus 1, and when we solve this both equation, we get x square plus y square is equal to a square plus b square, and x minus a plus b whole square plus y minus b whole square is equal to a plus b square. These are the two circles, equation of circle. First one is x square plus y square is equal to a square plus b square. So this is a circle with center 0, comma 0, and with radius root under a square plus b square. And second circle is center at a plus b and b minus a with radius root under a square plus b square. So now we have the coordinate of center of this both circle. So apply the distance formula to find the distance between the center, and the distance between the center is given by root under a plus b whole square plus a minus b whole square, and when you solve this we get root 2 into root under a square plus b square, and root under a square plus b square is radius for both circle. So we get root 2 times radius of either circle. Clear? Okay, next question. Let A be the very good. What is your name? So next question. Let A be the center of the circle x square plus y square minus 2x minus 4y minus 20 is equal to 0. If the tangent at the point B 1 comma 7 and D 4 comma minus 2 on the circle meet at C, then find the area of quadrilateral ABCD. Okay, so we have a circle x square plus y square minus 2x minus 4y minus 20 is equal to 0, and A is the center for this circle. Okay, so we know that if we have a equation of circle in general form, that form is x square plus y square plus 2gx plus 2fy plus c is equal to 0, then what is the coordinate of center? That is minus z comma minus f. So we can calculate the coordinate of A. Okay, then it is given that if the tangent at the point B 1 comma 7 and D 4 comma minus 2 on the circle. So these 2 points lie on a circle B 1 comma 7 and D 4 comma minus 2. And when we draw the tangent at this both point, that tangents meet at C. Okay, so then we get a quadrilateral, that is ABCD. So we have to find the area of this quadrilateral ABCD. Options 78, 75, 79, 85. Okay, so try this question. Okay, Uday, try this question. At first, try to draw the figure. If the equation is given in general form for a circle, then coordinate of center is minus z comma minus a, and radius is root under g square plus f square minus c. And general form of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So you can compare the given equation of circle with the general form and try to find the value of g and f. Okay, 1 comma 2 is center. What is radius? Okay, let's solve. So correct answer is option B, 75. Okay, the formula. The first formula is, if we know the 2 points of a line, then slope is given by, slope of the line is y2 minus y1 by x2 minus x1. Okay, and the distance formula, if A and B are 2 points, coordinate of A is x1 y1 and B is x2 y2, then distance AB is root under x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so this is the figure. We have a circle with center 1 comma 2. So how we get this 1 comma 2? Compare the given equation of circle with the general form and then try to find the value of g and f. And when you have the value of g and f, the coordinate of center is minus z comma minus f. So the value we get 1 comma 2. Okay, so now the coordinate of b is 1 comma 7 and coordinate of d is 4 comma minus 2. We draw the two tangent from this 2 point, that is intersect at a point C. So this we get a quadrilateral, that is ABCD. We have to find the area of this quadrilateral, and we know that the formula for area of quadrilateral is that is AB into BC. So we have to find the length AB and the length BC. We can easily calculate by the distance formula, but we at first we have to find the coordinate of point C. Okay, so let's find. So what is slope of AB? As the point A is 1 comma 2 and point B is 1 comma 7. So by using the formula of slope, we get slope of AB is 7 minus 2 by 1 minus 1, that is infinity. Okay, as 1 minus 1 is 0. So we get slope of AB is infinity. It implies that the line AB is perpendicular to the x-axis, that is parallel to y-axis. Okay. So as the slope of AB is infinity, so slope of BC is, as the line BC is perpendicular to AB and AB is infinity, so the line is BC is perpendicular to AB. So the line BC must be horizontal line. That means the line is parallel to x-axis. So the slope of BC is 0, as the slope of x-axis is 0, and if two lines is parallel, then slope are same. So slope of BC is 0. Okay. So what is equation of BC? So as the slope is 0, so that line must be parallel to x-axis. And if we know, how can we give the equation of a line that is parallel to x-axis and passing through a point? And that point is B 1 comma 7. So as this line is parallel to x-axis, so the y coordinate is always fixed. So we can write the equation of line BC as y is equal to 7. Clear? Any doubt? Very good. Now, slope of AD. So we apply the formula of slope. So we get 2 plus 2 by 1 minus 4, that is minus 4 by 3. Okay. So slope of AD is minus 4 by 3. Okay. And slope of DC, the line DC is perpendicular to the line AD. So we can find the slope of DC with the help of slope of AD, because if two lines are perpendicular, then what is the relation between the slope? If M1 is the slope of first line, M2 is the slope of second line, then M1 into M2 is minus 1. So from that we get slope of DC is 3 by 4. So equation of DC. Now to find equation of DC, the line DC is passing through point D, that is 4 comma minus 2, and the slope is 3 by 4. So apply the point slope form to find the equation of the straight line, and that is y plus 2 y minus y naught is equal to m into x minus x naught. So from here we get y plus 2 is equal to 3 by 4 into x minus 4. Simplify this, we get 3x minus 4y minus 20 is equal to 0. That is your second equation. So equation of BC is y is equal to 7 and equation of DC is 3x minus 4y minus 20 is equal to 0. So if we solve this both equation, we get a intersecting point, that is point C. And when we solve, we get C is equal to 16 comma 7. So now we have coordinate of C, that is 16 comma 7. Okay. So at first find the distance AB with the help of distance formula, and we can also find this distance because this is radius and radius is 5. So AB is 5 and BC, we have the coordinate of B and C. So apply the distance formula, we get 15. And the area of quadrilateral ABCD is AB into BC, that is 5 into 15, that is 75. Okay, clear? Right? Clear? Okay. So just wait for a moment. Okay, so next question. Find the equation of a circle concentric with the circle x square plus y square minus 6x plus 12y plus 15 is equal to 0 and has double of its area. Okay, so we have to find equation of circle, and information about that circle is the center of that circle is also the same center of that of the circle x square plus y square minus 6x plus 12y plus 15 is equal to 0. So at first find the center of this circle. Okay, and another information is has double of its area. So how we can calculate the area of a circle? What is the formula of area of circle? Use that formula and then okay. So which option is correct? Option A, x square plus y square minus 6x plus 12y minus 15 is equal to 0. Option B, x square plus y square minus 6x minus 12y plus 15 is equal to 0. Option C, x square plus y square minus 6x plus 12y plus 15 is equal to 0. And option D, none of the above. Center is same, but what about the radius? So for radius, there is given another information that area of the required circle is double of the area of the circle x square plus y square minus 6x plus 12y plus 15 is equal to 0. Okay. Try this question. What is the coordinate of center? Compare the given equation of circle with general form and find the value of g and f, because the coordinate of center is minus z comma minus f. We can also calculate the radius, because the radius is given by root under g square plus f square minus c. Okay. Let's check. So correct answer is option A, that is x square plus y square minus 6x plus 12y minus 15 is equal to 0. Okay. The formula that we use, first one is, if the equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0, then center is minus z comma minus f and radius is root under g square plus f square minus c. Okay. So the equation of circle having center x1 y1 and radius r is given by x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay, let's solve. So if we compare the equation x square plus y square minus 6x plus 12y plus 15 is equal to 0 with the general form, we get the value of g and f, and from where we get the coordinate of center, that is 3 comma minus 6. Okay. Now radius is root under g square plus f square minus c, that is root under 3 square plus minus 6 whole square minus 15, that is root 30. Okay. Now area of circle is pi r square, that is pi into root 30 whole square, that is 30 into pi, and it is given that area of required circle is 2 into area of given circle. So we get pi r square, that is 2 into 30 pi, that is 60 pi. So we get r square is equal to 60 So we get r is equal to 2 into root 15. Okay. So now we have coordinate of center and also the radius. So equation of required circle is x minus 3 whole square plus y plus 6 whole square is equal to 2 into root 15 whole square. So from here we get x square plus 9 minus 6x plus y square plus 36 plus 12y is equal to 60. That is x square plus y square minus 6x plus 12y minus 15 is equal to 0. Clear? Okay. Next question. The equation of the locus of the midpoint of the chord of the circle 4x square plus 4y square minus 12x plus 4y plus 1 is equal to 0, that subtend an angle of 2 pi by 3 at its center is. So we have to find equation of the locus of the midpoints. Okay. And midpoints of the chord. So we have a circle 4x square plus 4y square minus 12x plus 4y plus 1 is equal to 0. And we have a chord for that circle that subtend an angle of 2 pi by 3 at the center. So at first draw the figure, draw the chord and make an angle that subtend an angle 2 pi by 3 at the center. Okay. And then we have to find the locus of midpoint of the chord. Okay. Given options are option A x square plus y square plus 3x minus y plus 31 by 16 is equal to 0. Option B x square plus y square minus 3x plus y plus 31 by 16 is equal to 0. Option C x square plus y square minus 3x plus y minus 31 by 16 is equal to 0. And option D none of the above. Okay, so try this question. What is the coordinate of center? P by 2 comma minus 1 by 2. Okay. Okay, let's solve. Correct answer is option B, that is x square plus y square minus 3x plus y plus 31 by 16 is equal to 0. The formula that we use, the first one is equation of circle with center x1 y1 radius r is given by x minus x1 whole square plus y minus y1 whole square is equal to r square. Okay. So we draw the figure. So observe this figure. We have a circle of equation 4x square plus 4y square minus 12x plus 4y plus 1 is equal to 0. Okay. And then we draw a chord that is AB that subtends an angle of 2 pi by 3 at the center. Okay. And Q is the midpoint of this chord, that is H comma K. And when we that line CQ that bisect the chord So AQ equal to QB, and also it bisect the angle. The angle ACQ is pi by 3. Okay. Now take radius as r. So now we can calculate the center of this circle using the general form. Coordinate of center is minus z comma minus f. Okay. So let QHK be the midpoint of the chord AB. So angle ACQ is equal to angle BCQ, that is pi by 3, because this line CQ bisect this angle and this whole angle is 2 pi by 3. So ACQ and BCQ is pi by 3, and coordinate of center is 3 by 2 and minus 1 by 2. Okay. And radius is 3 by 2. Okay. Now we have to find the locus of the point QH comma Q. That means we have to find the relation with H and K. Okay. So let's find out. So now the length CQ, length from the center to that midpoint, is using the trigonometry, we get r cos pi by 3. That is r by 2, as the value of pi by cos pi by 3 is 1 by 2. So we get r by 2, that is 3 by 4. Okay. So the locus of the point HK is nothing but the circle with same center as the circle 4x square plus 4y square minus 12x plus 4y plus 1 is equal to 0, and but with the radius 3 by 4. Okay, so apply the formula of circle. So you get h minus 3 by 2 whole square plus k plus 1 by 2 whole square is equal to 3 by 4 whole square. So locus of HK is, replace h and k by x and y, simplify the above equation. You get x square plus y square minus 3x plus y plus 31 by 16 is equal to 0. So locus of the midpoint of the chord HK is nothing but again a circle with the same center as the circle 4x square 4 plus 4y square minus 12x plus 4y plus 1 is equal to 0, but with the radius 3 by 4, with the radius CQ. Okay, clear? Next question. Let PQ and RS be tangent at the extremities of the diameter PR of the circle of radius R. Okay. If PS and RQ intersect at a point X on the circumference of the circle, then 2R equals option root under PQ into RS, option B PQ plus RS by 2, option C 2PQ into RS by PQ plus RS, and option D root under PQ square plus RS square by 2. So try this question. At first draw the figure. So we have a circle with diameter PR. So take a circle and draw a diameter PR, and then draw tangent at P and R. Tangent at extremities of the diameter. So that tangent are PQ and RS. Then the radius of circle is R, and also intersect the line PS and RQ, and the intersecting point is lie on the circumference of circle, and that point is X. Okay, then what is the value of diameter? Draw the figure. Use the trigonometry to find the length. When you draw this figure, you get a right angle triangle. Let's see how. So correct answer is option A, that is root under PQ into RS, the formula that we use. So it is a known property that any diameter of the circle will subtend a right angle at that point x on the circumference. This means that regardless of where point x is located along the circle is, as long as it lies on the circumference, any segment drawn from the end point of diameter to x will always form a right angle. So the angle made at a point x, that is right angle. Okay. So this is the figure. So we have a circle and diameter RP. Then we draw the tangent at a point R and at a point P. And that tangent is RS and PQ. Okay. So these are the tangent PQ and RS. Then we intersect PS and QR. And the intersecting point, that is X, lie on a circle. Clear? And according to the property, the angle RXP is 90 degree, because any diameter of the circle will subtend a right angle at the point x on the circumference. Clear? This is a known property. So the angle must be 90 degree. So now we have to find the length of RP. So we get two right angle triangle RPQ and SRP. As this angle is 90 degree, RXP is 90 degree. So if we take the QRP as theta, then SPR is 90 degree minus theta. Clear? So tan theta is equal to PQ by 2R, and tan 90 degree minus theta is RS by 2R, and tan 90 degree minus theta is cot theta. So tan theta is PQ by 2R and cot theta is RS by 2R. From here we get tan theta into cot theta is equal to PQ into RS by 4R square, and tan theta into cot theta is 1. From here we get 4R square is equal to PQ into RS. When we take square root both sides, we get 2R is equal to root under PQ into RS. So 2R, that means the diameter is root under PQ into RS. Clear? Any doubt? Question. If the line AX plus BY is equal to 0 touches the circle x square plus y square plus 2x plus 4y is equal to 0 and is normal to the circle x square plus y square minus 4x plus 2y minus 3 is equal to 0, then what is the value of A comma B? Options 2 comma 1, option B 1 comma minus 2, option C 1 comma 2, and option D minus 1 comma 2. Okay. So you can find the relation between A and B and then check each option, which option, by hit and trial method, which option satisfy that condition. Okay. So as it is given that the line AX plus BY is equal to 0 touch the circle and is normal to the circle. So if any line is normal to the circle, then what property it follows? Let's solve. Correct answer is option C, that is 1 comma 2. So if the equation of circle is x square plus y square plus 2fx plus 2gy plus c is equal to 0, then from the standard form, the center h comma k of the circle is h is equal to minus f and k is equal to minus b. Okay. Now If the line ax plus by is equal to 0 is being normal to a circle, then it implies that it passes through the center of the circle. Okay. So as this line is normal to the second circle, it means this passes through the center of the second circle, and we can find the center of the second circle by using the formula that we discussed. So the center of the second circle is 2 comma minus 1. So substitute this 2 comma minus 1 in the line equation. We get a into 2 plus b into minus 1 is equal to 0. From here we get 2a minus b is equal to 0. That is b is equal to 2a. Now you use the hit and trial method, check each option. So the only option, that is 1 comma 2, satisfy this condition. A b is equal to 2a. So the value of a comma b is 1 comma 2. Okay. Next question. A circle touches the hypotenuse of a right angled triangle at its middle point and passes through the midpoint of the shorter side. If A and B, that is A is less than B, be the length of the side, then the radius is option A, B by A root under A square plus B square, option B, B by 2A root under A square minus B square, option C, B by 4A root under A square plus B square, and option D, none of these. Okay. So take this question as homework. Try this question. Okay. So as a hint, a circle touches the hypotenuse of a right angle triangle at its middle point. So at first draw the figure. You have a right angle triangle and the circle is touches the hypotenuse at the midpoint of that hypotenuse. Okay. And the second condition is that circle is passes through the midpoint of the shorter side, and is also given that A is less than B. Okay, and A and B is the length of the side. So coordinate of the triangle is a comma 0 and 0 comma b, and as a is less than b, so the side with point origin and a comma 0 the shorter side, so circle passes through the midpoint of the shorter side. Okay, so at first draw the figure and then find what is the value of the radius. Okay, so take this question as homework. So that's all for today. Any doubt? Okay, then thank you.
Hello students, in today's lecture we are going to learn about electromagnetic waves and this is theory part. Alright, this is our disclaimer. So firstly we will talk about the trend analysis of the chapter electromagnetic waves in JEE main examination. So according to last 5 years we can say the overall weightage of this chapter electromagnetic waves is 3 to 4%. Okay, and if we talk about yearly question distribution, so in 2024 question asked from uh, EM wave, number of questions 1, and if we talk about their difficulty level, so we can say question was average. In 2023 question asked from EM wave and EM spectrum, number of questions 2. Okay, and if we talk about their difficulty level, so we can say question was easy. In 2022 question asked from again from EM wave, concept covered is equation of electromagnetic wave, number of questions 1, and question was average. Okay, in 2021 question asked from EM waves, number of questions 1, and their difficulty level easy. All right, in 2020 question asked from again from E naught upon B naught equal to C equation, and number of questions 1, and if we talk about their difficulty level, so we can say question was average. All right, so in today's lecture we will cover first electromagnetic waves and their characteristics. Then we will discuss about conduction current. After that, we will discuss Maxwell's displacement current. Then we will discuss Maxwell's equations. Then properties of electromagnetic waves. All right. Then we will talk about transverse nature of electromagnetic waves. Then spectrum of electromagnetic radiation. Then we will discuss various electromagnetic radiations. All right. After that, applications of electromagnetic spectrum, and last, summary. Okay, so these are the concepts which we will discuss in today's lecture. All right, everyone. So first is electromagnetic waves and their characteristics. So what is electromagnetic waves? Please answer. Basically, electromagnetic waves are those waves in which electric and magnetic fields vary sinusoidally in space with time. Okay, or we can say electromagnetic waves are made up of oscillating electric and magnetic fields that are perpendicular to each other. Okay, so here electric and magnetic fields are mutually perpendicular to each other. All right, but one important point, uh, each field, electric field and magnetic field, is perpendicular to direction of propagation of wave. Okay, so this is the electromagnetic wave. So Maxwell's theory showed that these waves travel through a vacuum at a constant speed, uh, c equal to 1 upon under root mu naught epsilon naught. Okay, so this equation predicted by the Maxwell. Maxwell's theory predicted the electromagnetic waves of all frequencies. Okay, and the speed is, you know, c is equal to 1 upon uh, under root mu naught upon epsilon naught. All right, and we already discussed about the mu naught and epsilon naught in the chapter electrostatics and magnetism and matter. Also in moving charges in magnetism. All right, where mu naught is the magnetic permeability, and what about epsilon naught? So here epsilon naught is the electric permeability of vacuum. All right, and we know their value. So mu naught is equal to 4 pi into 10 to the power minus 7 Tesla meter per ampere, whereas epsilon naught is equal to 8.85 into 10 to the power minus 12 coulomb square per Newton per meter square. Okay, so we know the value of mu naught. Yes or no? We know the value of epsilon naught. So just substitute the value of mu naught and epsilon naught. All right, and find out the value of C. Please solve this term. So substituting these values in the above relation, which relation? In this relation, you will be get C equal to this one. C equal to 1 upon 4 pi into 10 to the power minus 7 into 8.85 into 10 to the power minus 12 whole power 1 by 2. So when we solving this calculation, all right, this calculation, you will be get 3.0 into 10 to the power 8 meter per second. Okay, so this is the speed of light. All right, and this is very important term. So all the electromagnetic waves are of the transverse nature. What is the meaning of transverse nature? It means their electric and magnetic fields oscillate perpendicular to the direction of wave travel. Okay, so we can say all the electromagnetic waves are of the transverse nature, whose speed depends upon the medium, but their frequency does not depend on the medium. Okay, so here we can say the frequency remains constant regardless of the medium. All right, so transverse waves can be polarized. All right, like electromagnetic waves can be polarized, which means their vibrations can be restricted to a single direction. Okay, and this property is useful in applications like polarized sunglasses or communication systems. And if we talk about the energy and momentum, so we can say energy and momentum is being transported with the electromagnetic waves. Okay, it means uh, here energy and momentum which can be transferred to objects they encounter. All right, and this is why sunlight can warm your skin or exert pressure on the surfaces like solar cells in space. Next is conduction current. What is conduction current? It is a current in the electric circuit which arises due to the flow of electrons in the connecting wires of the circuit. Okay, in a definite closed path. This is just like a normal current. Okay, here current flow of electrons through the connecting wires. Electric current in a circuit is flow of here, you know, flow of electrons through connecting wires, and it only happens when the path is complete or closed. Okay, this means the electrons move continuously in one direction around the loop, allowing energy to be transferred and devices to work. All right. Now, students, we will discuss Maxwell's displacement current. All right. So, displacement current, is a type of current that appears in a region where electric field is changing with time. Okay, even if no actual charge is flowing. If we talk about the mathematically, so we can say it is expressed as ID equal to epsilon naught d phi e upon dt. Here d phi e upon dt showing that it depends on the rate of change of uh, electric flux. Okay. So the generalized form of Ampere's law is close integration v dot dl equal to mu naught IC plus ID is equal to mu naught IC plus epsilon naught into d phi e upon dt. Clear? This is the generalized form. Okay. So here IC is, look at here, IC is what? IC is conduction current and ID is displacement current. So when we substitute the value of ID, which is we know ID equal to epsilon naught d phi e upon dt. So close integration b dot dl becomes, so here mu naught is a common in both terms. So we will take it outside. So it will become mu naught IC plus epsilon naught d phi e upon dt. Okay, and students, this connection ensures that magnetic fields are properly described even in regions like capacitors where no real currents flows. All right. Okay, now clear? Yes or no? Sudhanshu, good evening. All right. So we know IC is the conduction current. Now we will discuss about the Maxwell's equations. Okay. So in 1862, James Clerk Maxwell's formulated a set of four equations. Okay, and that four equations describe the fundamental laws of electricity and magnetism. Okay, and known as Maxwell's equations. Okay, so here we will unify electric and magnetic phenomena into a single theoretical framework. So first is Gauss's law for electrostatics. All right. So if we talk about the Gauss's law for electrostatics, so we can say it tells us that the total electric flux passing through a closed surface is directly proportional to the net charge, net electric charge enclosed by the closed surface, okay, divided by epsilon naught. Okay, so we can say Q enclosed divided by epsilon naught. Clear? It means we can say if there is a more charge inside, more electric fields lines will pass through the surface. So mathematically expressed as a closed integration E dot ds is equal to Q upon epsilon naught. So here Q, listen carefully, Q is the total charge enclosed by the closed surface and divided by epsilon naught. Second is Gauss's law for magnetism. So, Gauss's law for magnetism states that the total magnetic flux through any closed surface is always zero, which implies that magnetic monopoles, isolated north or s- south poles, so we can say this is not exist. In other words, magnetic field lines always form closed loops. Monopole does not exist. If we talk about mathematically expression, so we can say closed integration v dot ds is equal to 0. So from this analysis, we can say we have two equations here. First, closed integration E dot ds is equal to q upon epsilon naught. Second equation, we have a closed integration B dot ds is equal to 0. Okay, let's see third equation. Third is Faraday's law of electromagnetic induction. And what is that? So we can say Faraday's law of electromagnetic induction tells us that whenever the magnetic flux through a circuit changes with time, an electromotive force, also known as EMF, is induced in that circuit. Okay, so the faster the magnetic field changes, the stronger the induced EMF. Mathematically, Faraday's laws of electromagnetic induction, we can write like closed integration E dot dl is equal to minus d phi b upon dt. Now, here a question arises. What uh, what shows the negative sign? This is. Think about it and tell me the answer. Why there is a negative sign? Anyone? Yeah, please answer the question. Why there is a negative sign? Anyone? Yes. Please answer. Yes. Anyone? Sudhanshu, Varsha, VK, Karthik. Please answer. Yes. Why there is a negative sign? So here the negative sign shows the direction of induced EMF, okay, which opposes the change in flux. And next is Ampere's Maxwell's law. So Ampere's Maxwell's law extends Ampere's original idea by including the displacement current, okay, and which arises when the electric field changes with time. All right. So it states that uh, the total magnetic field around a closed loop is produced not only by the conduction current IC but also by the displacement current, okay, ID. So we have a mathematical expression for Ampere's Maxwell's law. This is closed integration B dot dl is equal to mu naught IC plus epsilon naught d phi E upon dt. Okay, and students, this correction uh, ensures the law holds true even in situations like inside a capacitor where no actual charge flows. Okay, so here we have a four equations and known as Maxwell's equations. These are the basic building blocks. Okay, any doubt here? All right. Now we will discuss properties of electromagnetic waves. So if the electromagnetic waves is traveling along the positive direction of x-axis, the electric field is oscillating parallel to y-axis. Okay, and magnetic field is oscillating parallel to z-axis. Clear? Now, suppose if the electromagnetic wave is traveling along positive direction of y-axis, okay, then what will be the electric field, direction of oscillating electric field and magnetic field oscillation, oscillating magnetic field? Tell me. So we can say here, look at here, traveling along the positive direction of x-axis, okay, the electric field is oscillating parallel to y-axis. So in that case, here uh, the wave is traveling along the positive direction of y-axis. Okay, so in that case, electric field is oscillating parallel to z-axis and magnetic field is oscillating parallel to x-axis. They are mutually perpendicular to each other. Okay, so here we have two equations. First, E is equal to E naught sine omega t minus kx j cap, and second, B equal to B naught sine omega t minus kx k cap. Okay, so what is E naught and B naught? E naught and B naught are amplitudes of the fields. Okay, which indicates the maximum strength of each field during oscillation. All right. So there is a relation between E naught, B naught and the speed of light, that is C is equal to E naught upon B naught, which is equal to 1 upon under root epsilon naught mu naught. And this is very important relation for the exam. And this relation showing that the speed of light depends on the electric permittivity epsilon naught and magnetic permeability mu naught of free space. Okay. So if we talk about the rate of flow of energy in electromagnetic wave, so we can say it is described by the vector S, and this S vector known as Poynting vector. Okay, so if we talk about the Poynting vector, so we can say Poynting vector S is equal to 1 upon mu naught into E cross B, cross product of electric field and magnetic field divided by mu naught. We can say electric the energy carried by electromagnetic wave flows in the direction of wave propagation and is described by the Poynting vector S. Okay, so when we take the time average of this vector, okay, over one full cycle of the wave, so we get the wave intensity. And since the average of sine square omega t minus kx over a cycle is 1 by 2, so the intensity becomes I equal to S average is equal to E naught V naught divided by 2 mu naught, which is equal to E naught square divided by 2 mu naught into C, which is equal to C B naught square divided by 2 mu naught watt per meter square. Okay, watt per meter square is the unit. Alright, unit of I. Clear, students? Any doubt here? Yes, anyone? Sudhanshu, Varsha, Karthik? Any doubt? Alright. So next is average energy, or we can say total average energy. So how we can calculate the total average energy stored in an electromagnetic wave per unit volume? So listen everyone, we will here we talked about the electromagnetic wave. So we can use two terms, electric energy density or magnetic energy density. Okay, So the total average energy stored in an electromagnetic wave per unit volume is the sum of the energy in electric field and the magnetic field, and this is calculated by U equal to UE plus UB, and we know the value of UE, that is epsilon naught E naught square divided by 2 plus uh, B naught square divided by 2 mu naught, where each term represents the energy density due to the respective field. Okay, so we can say when an electromagnetic wave strikes a perfectly absorbing surface, it transfers momentum and exerts pressure. And the formula to calculate the radiation pressure P exerted on a perfectly absorbing surface, so we can say P equal to S by C. Okay, where what is S? S is the pointing vector representing energy flow, and C is the speed of light. Okay, everyone. And if the surface reflects the wave perfectly and the wave hits it head on, so the momentum transferred doubles. Why? Because the wave bounced back. So in that case, the momentum delivered is P equal to 2U divided by C, and the radiation pressure becomes P equal to 2S by C. Okay, and that is showing a stronger force on the surface. All right. So we know the energy density of the wave at any point is also described separately for each field. For the electric field, UE is equal to 1 by 2 epsilon naught E square, and for magnetic field, UB equal to 1 by 2 B square upon epsilon naught. Okay, so both UE and UB, okay, contributing to the total energy. Clear? And this is most important concept for the exam. Now, the momentum carried by the wave depends on whether the surface absorbs or reflects it. So, for an absorbing surface, the momentum delivered is P equal to U by C. And for a reflecting surface, we can say it is P equal to 2U upon C. Okay? And showing how reflection increases the impact. Any doubt? If you have any doubt, please ask. Anyone? Yes, Sudhanshu, Varsha, Karthik, PK. Any doubt here? Yes or no? Tell me. All right. So finally, uh, the energy of a single photon in a wave, we have the formula that is given by uh, energy of wave is equal to hc by lambda, or we can say E equal to hc by lambda. Okay, and what is c by lambda? That is mu, frequency. So we can say E equal to h mu, where h is Planck's constant and lambda is the wavelength and mu is the frequency. All right. Now, transverse nature of electromagnetic waves. This is the property of electromagnetic waves. Okay. So, what is the meaning of transverse nature? We already discussed. Yes or no? So, we can say, according to Maxwell's theory, electromagnetic waves are made up of electric and magnetic fields that change with time. Okay, so these fields are not only perpendicular to each other but also perpendicular to the direction in which the wave travels, forming a right angled structure in space, or we can say propagation to direction of wave propagation. So look at here in the figure, this one, the x axis, y axis and z axis. Okay, so here x axis shows what? So we can say uh, here the wave is moving along the x axis. Okay, so the electric field oscillates up and down along y axis. Look at here, up and down along y axis. All right, while the magnetic field oscillates in, okay, and out along the z axis. So this perfectly illustrates the transverse nature of electromagnetic waves, where all three directions, electric field, magnetic field and wave propagation, are mutually perpendicular. Okay, the angle between these directions should be 90 degree. Direction of electric field, magnetic field or wave propagation. All right. So here this is the spectrum of electromagnetic radiation. Okay, so this is the frequency measured in hertz and this is the wavelength measured in meter. Okay, you know we've got violet, blue, green, yellow, orange, red. Yes or no? So we can say the electromagnetic spectrum is a complete range of electromagnetic waves, which includes all types of radiations arranged in order of their frequency or wavelength. Students, this spectrum covers everything from low frequency radio waves to high frequency gamma rays, and that's showing how different forms of electromagnetic energy vary in their properties. So look at figure, you can see how the spectrum is divided into regions such as radio waves, microwaves, infrared, okay, visible light, ultraviolet, x-rays, gamma rays. Okay, so okay, each region has its own typical source, okay, uses and effects, and the visible light portion is just the teeny part of the entire spectrum. Okay, this one, visible light region is just a teeny part of the entire spectrum that our eyes can detect. All right, first gamma rays, x rays, ultraviolet, visible, infrared, microwave, short radio waves, television and FM radio, AM radio and long radio waves. All right, so this is very important concept for the exam. Now here a brief explanation about the radio waves, microwaves, infrared, light, ultraviolet, X-rays, gamma rays based on wavelength range, production and detection. Okay, so electromagnetic waves vary in wavelength and are produced by different processes. So radio waves are the longest and are made by electrons movement in areas. Microwaves are made up by special valves. Infrared from atomic vibrations. Visible light comes from the electrons changing energy levels. Ultraviolet is from inner electron. Okay, X-rays uh, tubes. Okay, X-rays tubes or inner cell electrons. Gamma rays from radioactive decay or nucleus and nuclear transition. Okay, and if we talk about their detection, so we can say light detected by eye photocells, or we can say photocells photographic film. Similarly, by other uh, waves. All right. So here now we will discuss various electromagnetic radiations, and this is very important and we can say very easy. So first we have gamma rays. The main source of gamma rays are the natural and artificial radioactive substances. These rays affect the photographic plate and mainly used in treatment of cancer disease. Okay, these rays can expose photographic plates and useful in medical treatments such as targeting and destroying cancer cells. Okay, everyone, clear? Any doubt here? Yes or no? All right. The second is X rays. Students, X rays are generated when fast moving cathode rays strike a metal target with a high melting point. Okay, they can pass through transparent materials and also affect photographic plates. Their primary applications include medical imaging to detect bone fracture or uh, we can say structure inside the body, and they are also used in analyzing crystal structure. Okay, third is ultraviolet rays. A major part of the radiation received from sun consists of the ultraviolet radiation. Its other sources are the electric discharge tube, carbon arc, etc. These radiations are mainly used in excitation of photoelectric effect and to kill the bacteria of many disease. Or we can say these rays are important in triggering the photoelectric effect and commonly used in kill bacteria, making them useful in stabilization and disease prevention. And next is visible light. So visible light is a part of the electromagnetic spectrum that we can see our eyes. Okay, it is emitted by objects that are heated until they glow. Okay, such as electric bulbs, sodium lamps, and fluorescent tubes. This light allows us to perceive the world around us and is essential for everyday vision. Yes or no? This is essential or not? Yes. Sudhanshu, Varsha, Karthik, VK, this is visible light is essential or not? Tell me. All right. Yes, this is essential. Okay. This is essential. Okay. Next is thermal or infrared waves. Thermal or infrared waves are emitted by objects when they are heated. Okay. And they are carry a strong heating effect. Okay. So since glass tends to absorb these waves, so scientists use a rock salt prism instead of a glass prism to study them. So due to their ability to generate warmth, infrared waves are commonly used by doctors for therapeutic treatments. Next is microwaves. These waves are produced by the spark discharge or magnetron bulb, and they are detected using crystal or semiconductor detectors. These bulbs are specifically useful in radar systems and for long distance communication. Why? Because they can travel for and carry signals effectively. Okay. Next is radio waves. Basically, radio waves are produced when high frequency alternating current flows through an electric conductor. These waves are picked up by a tank circuit in radio receivers or transmitters, making them uh, essential for broadcasting and wireless communication. Okay, clear? Yes or no? Any doubt here? All right. Now, students, we will discuss applications of electromagnetic spectrum. So, first, if we talk about the radio waves, so we can say radio waves are used in radar and radio broadcasting. Why? Think about it. Because uh, they can travel long distances and penetrate through the atmosphere, making them ideal for communication and detection purposes. Okay. Second, microwaves. So if we talk about the microwaves, so we can say microwaves are used in long distance wireless communications via satellites, as they can carry large amounts of data and are less affected by atmospheric conditions. Third, infrared, or fourth, visible. Fifth, ultraviolet. Okay. So if we talk about these waves, so we can say infrared, visible, and ultraviolet radiations help scientists study the structure of molecules by interacting with them in different ways, such as causing vibrations or electronic transitions that reveals molecular details. And if we talk about diffraction of X-rays, so we can say in this phenomena, or we can say X-rays, when diffracted by crystals, produced pattern that allow researchers to understand the internal arrangement of atoms in the crystal, okay, making them essential tools in studying crystal structures. So these are very important concepts, or we can say these applications of electromagnetic spectrum is very important for the exam. Okay, everyone. So here, now we summarize the concepts. First, we discussed electromagnetic waves and their characteristics. So we know electromagnetic waves are oscillations of electric and magnetic fields that travel through space at the speed of light. Then Maxwell's equations. So Maxwell's equations are a set of four fundamental laws that describe how electric and magnetic fields interact and propagate. Okay, these equations form the foundation of classical electromagnetism and are essential for understanding the behavior of electric and magnetic fields in the space and time. Then Gauss's law for electricity, electric charge produced an electric field. Then Gauss's law for magnetism, okay, monopole does not exist. Then Faraday's law of induction. This law describes how a changing magnetic field induces an electric field. It is given by the formula is del cross E is equal to minus del V upon del T. Then Ampere circuital law, electric currents and changing electric fields produce a magnetic field. Then transverse nature of electromagnetic waves. So here one question for you. I'm expecting answer from everyone. Okay, so are you ready for the question? The question is, what is the meaning of transverse nature of electromagnetic waves? Yes, tell me. Anyone? Yes, please answer. Okay. It means oscillations of electric and magnetic fields are perpendicular to the direction of wave propagation, or they are also perpendicular to each other. Okay. Then spectrum of electromagnetic radiation. The electromagnetic spectrum encompasses of all types of electromagnetic radiations arranged by wavelength or frequency. Okay. It ranges from long wavelength, low frequency radio waves to short wavelength, high frequency gamma rays. Okay. So the spectrum includes in order of increasing frequency, radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays and gamma rays. Clear everyone? Thank you for your attention. That's all for the today. Now students, we will solve some practice questions based on electromagnetic waves. So I think you are ready. Yes or no? Okay. So we will solve now practice questions. Clear? Hello students. Now we will solve some practice questions based on electromagnetic waves. Okay. So this is our disclaimer. Here we will solve some practice questions based on electromagnetic waves. So students, our first question: during the propagation of electromagnetic waves in a medium, okay. So here we have a four options, or we can say four statements, and you have to read the first statement and find out the correct option. The first statement is during the propagation of electromagnetic waves in a medium. Option A: electric energy density is double of the magnetic energy density. Option B: electric energy density is half of the magnetic energy density. Option C: electric energy density is equal to the magnetic energy density. And option D: both electric and magnetic energy densities are zero. And this question asked in JEE in 2014. Okay, so which option is correct? Think about it. Here we need to find out the how electric energy density and magnetic energy density are related, okay, to each other. Please solve this question, everyone, and find out the correct one. You have some time. Please solve. Okay, A option is correct. B, D. Which one is correct? Yeah, find out the correct option. Okay, anyone? All right. So the correct option is option C. Okay, let's solve this question. So let's now look at its situation. When electromagnetic waves propagate in a medium, we need to find the relation between electric and magnetic energy density. Okay, so we will start from this concept. In an electromagnetic wave, electric field E and magnetic field B are perpendicular to each other. Okay, and the direction of wave propagation is also perpendicular to both. Yes or no? Therefore, the energy density associated with these electric and magnetic fields is electric energy density UE is equal to 1 by 2 E E square. Here this epsilon like E is the, look at here, this one 1 by 2, this is epsilon E square. Okay, so UE represents the electrical energy density, or electrical energy density means energy density associated with electric field. This thing is given to us here, and look, a small UE is written here. It means represents density. Now epsilon is the permittivity of medium and is the magnitude of electric field. Similarly, we know the magnetic energy density, that is UB equal to 1 by 2 B square upon mu naught. Okay, where mu is the permeability of the medium and B is the magnitude of the magnetic field. So there is a relation between medium uh, uh, in medium and the speed of light v. So v equal to 1 upon under root epsilon into mu. So relation between E and B in a medium is E equal to VB. So just substitute the value and put the given terms. You will be get UE, that is 1 by 2 epsilon B upon under root epsilon mu whole square. Similarly, when we solving this, you will be get UE is equal to 1 by 2 B square upon mu, which is equal to UB. So the UE or equal to UB, it means an electromagnetic wave in a medium, electrical energy density is equal to the magnetic energy density is what? U equal to UV. So the correct answer is C. Okay. Next question. A perfectly reflecting mirror has an area of 1 centimeter square. Light energy is allowed to fall on it for 1 hour at a rate of 10 watt per centimeter square. The force acting on the mirror is what? So here you have to find out the force. Okay. So here we have a uh, four options. Option A 6.7 into 10 to the power minus 8 Newton. Option B 2.3 into 10 to the power minus 4 Newton. Option C 10 to the power minus 3 Newton. And option D 0. So tell me which option is correct, A, B, C or D. Please solve this question and find out the correct one. Okay, please solve. Which one is correct? Find out the correct answer. Anyone? So the correct option will be option A. That's all this question. So students, to determine the force acting on a perfectly reflecting mirror due to incident light, here we will use the concept of momentum transfer from light to the mirror. Okay. So when light reflects off a surface, it imparts twice the momentum compared to when it is absorbed because the direction of momentum changes. So if we talk about the power per unit area of the light, that is given 10 watt per centimeter square. Okay. And the area of the mirror is 1 centimeter square. So P equal to, intensity into area. So just substitute the values, you will be get the value of P. So now we will calculate the energy incident on the mirror in 1 hour. So equal to P into time. Just substitute the value and perform the calculation. You will be get equal to 36000 joule. It means we can say using that concept, uh, we can determine the momentum transferred to the mirror. So we know the formula equal to PC. So just P equal to what? E upon C. So just put the value of E, that is 36000 joule, divided by C, that is 3 into 10 raised to power 8 meter per second. So after performing calculation, you will be get 1.2 into 10 to the power minus 4 kilogram meter per second. So now we will calculate the force exerted on the mirror. So we know the force, rate of change of momentum. So delta P upon delta T. So we know the value of delta P. Yes or no? So just put the value of delta P, that is 2P, and delta T, that is 3600 uh, 3600 second. Okay. So when we substitute this value and find out the calculation, you will be get force force acting on the mirror, that is 6.67 into 10 to the power minus 8 Newton. All right, clear? Next question. Instantaneous displacement of current of 1 ampere in the space between the parallel plates of a 1 microfarad capacitor can be established by changing potential difference of what? These are options. Option A, 10 to the power minus 6 volt per second. Option B, 10 to the power 6 volt per second. Option C, 10 to the power minus 8 volt per second. And option D, 10 to the power 8 volt per second. So which one is correct? Please solve this question and find out the correct option. Yes, please solve. Which one is correct? So, correct option will be option B. Okay. So given the displacement current that is 1.0 ampere and the value of C that is 1 microfarad. Micro means 10 to the power minus 10 to the power minus 6. Okay. So we can say 1 into 10 to the power minus 6 farad. So we know the formula to calculate the displacement current in a capacitor. So ID equal to C into dV upon dt. Okay. So ID is the displacement current and C is the capacitance, and what about the dV upon dt? So dV upon dt is the rate of change of potential difference across the capacitor. So rearranging the formula to solve dV upon dt. So it will be dV upon dt is equal to ID upon C. So here just substitute the value of ID and C. It will be dV upon dt is equal to 1.0 ampere divided by 1 into 10 to the power minus 6 farad. When we performing this calculation, you will be get uh, this one 1.0 into 10 to the power minus 10 to the power 6 volt per second. So our option B is correct. All right. Next question. A large parallel plate capacitor whose plates have an area of 1 meter square and are separated from each other by 1 mm is being charged at a rate of 25 volt per second. If the dielectric between the plates has the dielectric constant 10, okay, then the displacement current at this instant is what? So in this question, you have to find out the displacement current. Okay. Given options, option A 25 microampere, option B 11 microampere, option C 2.2 microampere, and option D 1.1 microampere. So students, which option is correct? Please solve this question using the given information. Okay. So here we have a area 1 meter square and separation 1 mm and the dielectric the value of 10. Okay. And charged at a rate 25 volt per second. Clear? So please solve this question. You have some time and find out the correct option. Students, these questions helps you to build your problem solving skills and increase, or we can say boost your preparation. This is work as a booster. Okay. So please solve this question. You have some time. Please solve. Which one is correct? So the correct option will be option C. Let's solve this question. So here the important point is this. We know the formula of capacitance in case of dielectric, that is C equal to epsilon naught K into A divided by D. Now students, here epsilon naught is permittivity of space in vacuum, K is dielectric, A is the area, and D is separation. So just substitute the value. So epsilon naught 8.85 into 10 to the power minus 12 into the value of K 10, and the value of A, it means area here 1, and the A is the area that is given here. Okay, 1 meter square. Okay, so it will be 1 and divided by separation, that is 1 mm. 1 mm means 10 to the power minus 3. So when we performing this calculation, you will be get C equal to 8.85 into 10 to the power minus 8 farad. F is the unit of the capacitance, and we know the I, that is here differentiation of Cv with respect to time. So it will be C as it is dV upon dt. So just put the value of C, that is 8.85 into 10 to the power minus 8, and what is dV upon dt? The rate is given. Look at here. The rate of being charged at a rate of 25 volt per second. So that is 25. So when we multiplied both, you will be get 2.2 into 10 to the power minus 6, which is equal to 2.2 microampere. Okay. Next question. A parallel plate capacitor with plate area A and separation between the plates D is charged by a constant current I. Consider a plane surface of area A by 2 parallel to the plates and drawn simultaneously between the plates. The displacement current through this area is what? So in this question, you have to find out the displacement current. Clear? Given options: option A I, option B I by 2, option C I by 4, and option D I by 8. So which one is correct? Please solve this question. You have some time. Okay? Please solve. This is formula based question. Clear, students? There is a four option. You have to find out the correct one by solving this question. Please solve. All right. Anyone? Which one is correct? D. Anyone? B. The correct option will be option B. Okay. Let's solve this question. So we know the concept of displacement current. So to find the displacement current, we have a formula that is ID equal to epsilon naught d phi E upon dt. So charge on the capacitor plates at time t is Q equal to IT. So just here we will use electric field between plates at this instant. So it will be E equal to Q upon A into epsilon naught. So just substitute the value of Q, you will be get IT upon A epsilon naught. And we know the formula of electric flux through the given area, that is A by 2 into E, which is equal to IT upon 2 epsilon naught. So displacement current, it will be epsilon naught d phi E upon dt. Alright. So ED equal to epsilon naught. When we differentiate IT upon 2 epsilon naught with respect to time, it will become I by 2. So this is the differentiation of we can say here phi E. Alright. So you will be get I by 2. Next question. Select the correct statement from the following. So this question asked in JEE 2013. Given a question, given options. Option A, electromagnetic waves cannot travel in vacuum. Option B, electromagnetic waves are longitudinal waves. Option C, electromagnetic waves are produced by the charges moving with uniform velocity. Option D, electromagnetic waves carry both energy and momentum as they propagate through space. So students, you have to find out the correct option. Okay, so there is a four statements. Which one is correct? Please think about it and solve this question. You have a some time. Please solve. And this is a theoretical question, so I expecting answer from everyone. Okay, so please answer. Which one is correct? C. A. Okay. Anyone? So the correct option will be D. So we know an electromagnetic waves contains both electric field and magnetic field. Okay, it carry both energy and momentum according to de Broglie wave particle duality of radiations. So this is the electric field, this is magnetic field, and this is the wave direction of wave propagation. Okay, so D option is correct. P equal to H by lambda. Next question. In an apparatus, the electric field was found to oscillate with an amplitude of 18 volt per meter. The magnitude of oscillating magnetic field will be what? So here you have to find out the magnitude of the oscillating magnetic field. Given options, option A 4 into 10 to the power minus 6 Tesla, option B 6 into 10 to the power minus 8 Tesla, option C 9 into 10 to the power minus 9 Tesla, and option D 11 into 10 to the power minus 11 Tesla. So which one is correct? Please solve this question and find out the correct one. Okay, you have some time. Please solve. Magnitude of oscillating magnetic field, and given the amplitude 18 amplitude of electric field, that is 18 volt per meter. Okay, please solve. The correct option, option B. Okay, so that is in this question it is given that E naught, amplitude of electric field, that is 18 volt per meter. So we know there is a relation between B naught and E naught, that is B naught is equal to E naught upon C, and we know the value of E naught, that is 18 volt per meter. We know the value of C, that is universal 3 into 10 to the power 8. So when we substituting the values of E naught and C and performing calculation, you will be get B naught is equal to 6 into 10 to the power minus 8 Tesla. Okay. Next question. The magnetic field in a traveling electromagnetic wave has a peak value of 20 nano Tesla. The peak value of electric field strength is what? So here you have to find out the peak value of electric field strength. Given options, option A 3 volt per meter, option B 6 volt per meter, option C 9 volt per meter, and option D 12 volt per meter. And this question asked in JEE in 2030. So which one is correct, students? Please find out the correct one. Okay, this is a simple question. Here peak value is given, that is 20 nano Tesla, and here you have to find the peak value of electric field. This is just similar question uh, like a previous one. Okay, so please solve. You know the relation between E naught and B naught. So using that concept, please try to solve this. You have some time. Please solve, everyone. The correct option, option B. Okay. So we know the relation between E and B, that is mod of E equal to mod of B into C. Just substitute the values of mod of E and mod of B, that is given here 20 nano Tesla. Nano means 10 to the power minus 9, and C 3 into 10 to the power 8. Okay, so E becomes 6 volt per meter. Alright, thank you for your attention. That's all for the today. If you have any doubt, please ask. Anyone? Any doubt here? Alright, that's all for the today. Thank you for your attention. In next lecture, we will discuss ray optics. Okay, thank you.